Yep, there you go, now we have an error because the function signature does not match. So it always needs to match the exact same signature, okay? And also one more note over here, when subscribing to the event, make sure you only add the function name, meaning you do not add parentheses. We do not want to call the function, we just want to pass in the function itself as a reference. Okay, so now when the player presses the interact action, it's going to fire off this event, which in turn will call this function. So over here, let's do a debug.log just to see what this contains. For example, let's print out the callback context. Okay, so let's see. So here we are, and if I press on E, yep, there you go, I've got a nice event. Okay, great, so with this we know when the player presses a key. Now the next step is, how do we get the player class, how do we get this one to know when this is performed? And the answer is, we're going to do the exact same thing. We're going to make an event over here on the game input class, and the player will listen to that, which in turn the game input grabs from the input system. Again, the whole point is separating our concerns. So the player does not care about the input system, does not care about the interact action, it only wants to know when something related to interact happens. So over here, let's make that nice event. First of all, let's make it public because we want the player to access it. Then we need to add the event keyword. Next, we add the delegate type. Like I said, you can learn more about delegates in my dedicated video. You can create your own custom delegate for your event, or you can just follow the C# standard and just use the standard event handler, and this one exists inside system. So let's make sure to go up here and add using system, and this one has the event handler class. This one is pretty much the C# standard for events. As you can see, it returns void, it has an object for the sender, and an event args parameter. Like I mentioned in the events video, you are not forced to use this delegate. You can use whatever delegate you want. Like for example, you saw that the performed used an action delegate. So you can use anything you want, it's just that the event handler is the C# standard, so it's easier to follow. Unless you have a specific reason to deviate from the standard, you should probably use this one. So let's use this, and then finally for the name, usually you start the name with on and then whatever happened. So in our case, let's go with on interact action. Okay, so we have defined our event, and now for firing it, let's go down here into when we have the interact performed, and let's go into the event, and for firing it, it's pretty much exactly the same thing as calling a regular function, so we just call it with parentheses. Then usually for the object sender, this is a reference to whoever is sending this event, so usually the this keyword. And then for the event args, this is in case you want to send some arguments with the event. In our case, we don't really need to send any extra data for this one, just firing the event is going to be enough. So for that, we can use the constant event args.empty. Okay, so that's it. With this, we are firing an event. Except just like this, we're actually going to have one potential error. If we have no subscribers, no listeners to this event, then essentially this field will be null, so this one over here is going to trigger a null reference exception. Let's do a quick test just to see this happening. So here, if I press on E, yep, there you go, we have a null reference exception. So when working with events, you need to first test if there are any listeners, and only then do you actually trigger the event. So you do if this one is not null. If it is not null, that means there are some subscribers, so we can fire the event. So like this, it will work, but there's an even more compact way to do this, which is perfect for events. So instead of this, we've got our onInteract action, then we can add a question mark. This is called the null conditional operator. Basically, the code is going to execute from left to right. And then when it gets to this question mark, it's going to evaluate the left side. And if it is null, then the execution will stop right here on the question mark and will not throw any errors. Whereas if this one is not null, then it continues executing to the right. Except with this syntax, we have an error. We cannot put parentheses directly after the question mark. But what we can do is simply just call invoke, and that does the exact same thing. That calls a function. So what we have here is exactly the same thing that we had previously. So what we have over here and over here, these are the exact same thing. It's just this one is much nice, much more compact, and especially for events, this one is super useful. Okay, so with this, we are correctly firing for our event. Now let's actually listen to it. So let's go over here into the player class, and let's listen to our event. Let's do it on a private void start, make it on start and not on awake. This is a very important rule, which I'm actually going to cover in detail in the next lecture. But for now, just make sure to listen on start and not on awake. So over here, we access the game input. Then let's access the onInteract action event. And as usual, let's listen to it. So let's use press tab to listen to it. So it is exactly over here that we want to run our interact code. So let's go down into the handle interaction code that we had previously. So this one. So let's copy paste all of this code, put it up here. So we get the interaction, go into the object, and trigger the interact. Now obviously code duplication is a big no-no, so we're only duplicating our code just for a quick test, just to make sure it works. Once again, refactoring is super useful, so we're going to refactor this code to get rid of code duplication in the next lecture. But for now, we just want to test to make sure that this does work. So let's just remove the interact over here from the handle interactions. So the only interact function being called is over here when we have our actual input. So let's test and see if we can press to interact with the counter. Alright, so here we are, and as I move around, if I approach the counter, yep, there you go, we no longer have the automated interaction. And now if I'm facing the counter and I press the interact key, yep, there you go, here we have our nice interaction. Alright, awesome, so I can approach, I can interact and do whatever I want. Alright, so here we learned about C# events. These are super powerful, so if this is the first time you're hearing about them, then you've just added an awesome new tool to your toolbox. Definitely make sure you watch my dedicated video to learn about them in more detail. Events are super useful. The next thing we're going to need is just a visual to highlight the current selected counter, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to add a visual to our selected counter, and in doing so we're also going to learn about the very useful singleton pattern. Okay, so over here we already have the logic to identify the counter in front of the player, and we can interact with it. However, whilst the logic works, there is no visual indicator at all, so let's add that. Now, as usual, the super quick and dirty way of doing it would be pretty simple. Over here on the player script, we could just directly enable a visual mesh on the target counter. So down here on the handle interaction, when we have this, over here we could tell the clear counter to enable some kind of visual. Technically that would work, but that would be some pretty dirty code. We would basically be making the player responsible for enabling some kind of visual, which would mean that we were mixing logic with visuals. Again, we always want to try separating the logic from the visuals as much as possible to keep our code nice and organized, so instead of doing the quick and dirty route, let's do it properly. Back in the editor, let's create a brand new C# script. Call this the selected counter visual. And now let's go into the prefab. Again, let's go inside it, so let's select the clear counter on the hierarchy, then on the inspector, let's open up, go inside the prefab. And now let's select the visual inside it, and let's duplicate this, so you can press Ctrl D to duplicate it. Let's name this one selected, and then inside there's a visual with a mesh filter and a mesh render. So over here, let's swap out the material. So let's click on the circle icon, and now included in the assets is this material, counter selected. So it's all the way, yep, up here, the counter selected. Basically, it's just a solid white color with a low alpha. So on the kitchen counter inside the select game object, let's make sure to use this one. With this, we have kind of like a ghost visual. So if we enable and disable this game object, we can see the difference. Also, let's do one tiny thing, which is right now we duplicated the actual visual, meaning that these objects are exactly the same, they have the exact same size, and when that happens, you might end up with some rendering bugs. If two meshes are on the exact same position, you might sometimes see the colors constantly flip back and forth. So in order to make sure that doesn't happen, let's make this one, the selected, a tiny bit bigger. So over here with the selected game object selected, on the inspector over here we've got the scale, and also we've got this nice little button here. If it's like this, then we can modify each proportion differently from one another. Whereas if we click, now these are all linked. So now modifying one will modify all of them, so let's put this on 1.01. Meaning this one is going to be literally just 1% bigger. So that's enough of a difference to make sure we don't have any rendering bugs. And by default, let's also start with the visual hidden. So let's do that not on the parent select game object, but rather on the kitchen counter inside of it. Let's make sure to disable this game object. By the way, the quick shortcut is Shift, Alt, and A. You can enable or disable the object, very useful. So let's start with this one disabled so that it's hidden. And basically the goal is that when this counter is selected, we're going to enable it and show this visual, and when it's not selected, we're going to disable it. Okay, so over here on the selected, let's add the script that we made, so the selected counter visual. Alright, so let's open it. Now here, first thing we need to know is which counter is selected. Meaning we need to know which counter the player is currently looking at. So let's go over here onto the player script, and let's basically just do some simple logic to keep track of the selected counter. So over here, let's make a field, so a private. Let's make it of type clear counter, and just call it the selected counter. Then down here we have our handle interactions logic. Okay, so we do all of this. We try to find a counter in front, and if we do find it, then we have it here. So here, let's just check if it's different. So if this clear counter, if the one in front is different from the current selected, then let's set the selected to this one. And let's also make sure to essentially unselect. So we want to make sure to set this one to null when there's nothing in front of the player. So if the raycast does not hit anything, then there's nothing in front of the player. So let's set the selected counter back into null. And also, if there is something, but that something does not have the clear counter script, then it's also not a counter. So over here, let's also do an else selected counter equals null. So basically, if there's a counter in front of the player, then it's going to set it. If not, then it's going to be null. Let's just do a simple debug.log to check on the selected counter, okay? And also, just briefly, now that we've made this selected counter logic, actually up here when we have our interact action, like we saw, we were previously copying some duplicated code, but now we no longer need this since we already know the selected counter. So over here, when we've got the interact action, let's just check if we do have a selected counter. So if it is not null, if so, then we go there and we call the interact function. So that's it, we no longer need all of this logic. Okay, that's great, so let's test. Back in the editor, let's go back into scenes, let's make sure to save the prefab. Make sure the script was attached, save it, and let's hit on play. And right now, if I'm down here, yep, there you go, we've got null, and as I approach, yep, there you go, that one is a clear counter, and if I move towards this one, yep, it's that one. Okay, so basically we are keeping track of the currently selected counter. Now basically we just need to notify the visual whenever this one changes. So when this one is pointing at that one, or pointing at null, or pointing at that one, we need to know when that happens. And for that, we basically have two options. Now one option is pretty much what I mentioned a while ago, which is over here we have the selected counter, so we can run some kind of logic on the selected counter. We can do that over here on the player. Then perhaps over here the counter would fire off some kind of event saying it has been selected, and then the counter visual would listen to that event and update itself. Now that approach would be useful if we wanted to add some kind of logic on the clear counter while selected, and that approach would also have the benefit where the visual counter would only listen to events on its own counter. So that's one approach, pretty much a very direct approach. But another one is very simple. The player would simply fire off an event whenever the selected counter changes, and then all of the counter visuals would listen to that event, then they would identify if the event relates to that counter, and if so, update their state. Now the benefit of this approach is that the logic doesn't get bothered with any selection logic. So over here the clear counter script never really knows if it's selected or not, and that's a good thing because it doesn't need to know. Although the potential con with that approach is that all of these selected counter visuals are all going to listen to the same event. So both approaches have pros and cons. Here let's go with the second approach where all the counters listen to a player event. The potential performance con doesn't really matter on a game of this scale. We're only going to have about a dozen counters, so even if 11 of them are just wasting on listening to the event, it's really not going to matter. And going with this approach will actually help us learn about the singleton pattern, which is extremely useful. So first, let's go over here onto the player class, and let's make the event that we're going to fire. So as usual, let's make it public so we can access it. Let's make it an event. And as usual, let's also use the standard event handler. Let's make sure to add using system. So here Visual Studio adds it automatically, okay. And let's call this on selected counter changed. Also, this is a great moment to learn about the event args. This is how you can extend a C# event in order to pass in some more data. So how you do it by following the C# standard is very simple. We just create a class. So over here, let's make a public class. Then for the name, usually you include the name of the event with event args at the end. So in this case, on selected counter changed, and then event args. Then on this class, we make it extend event args. And finally, inside the class, we add whatever data we want. Like for example, we want the current selected counter, so let's make a public clear counter and put the selected counter. Okay, so we have this nice event args with a bunch of extra data, and then over here on the event handler, we use the version that takes a generic and we pass in our event args. Again, I covered the generics in more detail in a separate video. Definitely go watch that one if you haven't seen it yet. C# generics are one of C#'s most powerful features. Okay, great, so we now have our nice event. Now let's fire it off. So let's go down here to when we're modifying the selected counter. So here it is, we've got all of these ones. So when we modify, let's fire off the event. So we go into this event, and as usual, let's use the question mark and then call invoke. Then for the object sender, it's going to be this, so pretty much the standard. And then for our custom event args, let's construct an object of that type. So construct a new object. And then inside we pass in the selected counter and we set it to this selected counter. Now, don't be confused by the fact that we're using the exact same name. If you actually mouse over the cursor, Visual Studio actually helps you by telling you which object refers to this. So with the cursor here, note how all of these are highlighted, but this one is not highlighted. That's because this is the field inside the onSelected CounterChanged event args, whereas this one out here is the object that we're referencing in here. So even though these two have the exact same name, here we're accessing the field inside of that, and we're assigning it to the reference that we have down here. Okay, so that's really it. We're firing off the event when the selected changes, and we're passing it in. And let's also make sure to do it over here, so let's copy and paste some code, and there you go, just like this. Except, of course, we can already see a bunch of code duplication. Usually that means it's time to refactor, so let's do that pretty quickly. Let's go down and make a brand new function. So let's make a private void. Let's call it setSelectedCounter. And we're going to receive a clear counter for the selected counter. Then over here we just set this .selectedCounter, so we're modifying the member variable with the one that we receive on the parameter. And then let's also fire off the event. So let's copy paste the event, just like this, the exact same thing. Okay, so that's it. And now up there, instead of code duplication, we just do this. So over here we set the clear counter, just call the function, pass in that one and get rid of this. And on that one, just pass in null, just like this, get rid of all of this. And here the same thing, just pass in null. All right, so with this, our code is much cleaner and everything still works exactly the same. So here we have everything done on the player side. Let's just get rid of our log. We no longer need this. So we're still handling the selected counter logic, and then down here we're firing off the event. Now all we need to do is go over here into the selected counter visual script. And here what we want to do is to listen to that event. In order to do that, we need a reference to the player object. Now, so far, when we've been listening to events, like for example on the player class, up here we were listening to some events on the game input, so there you go, the onInteract action. So for the game input reference, we just added it as a serialized field. We did this and then we dragged the reference directly. And technically we could do the same thing over here on the selected counter visual, but we're going to have like a dozen counters in our map, so it would be pretty tedious to drag and drop the player reference to every single one of them. So instead of using a serialized field, another approach is to use the singleton pattern. This one is an extremely useful programming pattern. It's very useful for things where you only have one instance of something. In this case, we're making this game single player, so we're only ever going to have a single player. By the way, here's one obvious quick note. Like I mentioned in the beginning of this course, after this video, there's going to be another one converting this game into multiplayer, and in that case, we will have multiple player instances. But this is also an excellent reminder of how refactoring code is perfectly fine. For right now, for this game, it is intended as single player, so for now we're going to use the singleton pattern. Then in the future, when we convert this to multiplayer, we will simply refactor that logic. Again, don't be afraid of refactoring code. It's a perfectly natural part of programming and game development. Okay, so let's implement the singleton pattern. This is actually super simple. The name sounds intimidating, but it really is very simple. Over here on the player script, let's make a public field. This one, let's make it static. If you don't know static, basically it means that this field belongs to the player class itself and not to any instance of a player. So for example, if you had 100 players, you would have 100 instances of move speed, you would have one for each player, but there would only be a single static field because this static field belongs to the class itself and not to any instance. So let's make a field of type player, and then for the name, the convention is to call it instance. And the reason why I'm using Pascal case here, so capitalized in the beginning, the reason for that is because this is actually not going to be a field, but instead it's going to be a property. Remember the naming rules that we covered in the beginning of this course. It's very important you follow your naming rules. Always be consistent so your code is easier to understand. So with that said, since this is the first time we're using a property, let me quickly explain what it is. Basically, it's the exact same thing as a regular variable, except you can add some logic when getting and setting that field. So here, let me write some quick code just to show the difference between a property and a regular field. So for a regular field, you would call this maybe instance field, something like this. So this is a regular field. Then you would have some kind of public static return a player and call it get instance field. Then over here, you would return the instance field. And then maybe another public static void set instance field, where you receive a player for the instance field. And you would set the player.instance field into this instance field. So this is how you do this logic with fields. And now with properties, you would do public static player, then call it instance. Then on the property itself, you open up the curly brackets. Inside the property, you put a get, then you return something. So for that something, usually a property has a field underneath it. So you'd have a private static player for the instance. That's a different name from this one. On the get, you would return that. And on the set, you would set the instance equals the value. If you're confused here, don't worry. Basically, I'm just repeating just so you can see the difference. Here we have a field with a get and a set function, so regular functions. And up here we have a property, and inside the property itself has a get and set functions, which can also do some logic, so you can do some logic in between, or you can just return the underlying value. So basically using a property is pretty much the exact same thing as using a separate get and set function. Also, one more bonus thing, which is that C# is smart enough to automatically create the underlying field for a certain property. So if you just want to do a get and a set, then you don't need to define all this. You can just define a property, and then inside you can just do get and set. And there you go, this code here works the exact same thing as we had previously, which in turn is the exact same thing as all the code we have here with a getter and a setter function. So here it is, a valid functional C# property. Now, I have to say that personally I very rarely use properties. In fact, the only place where I use them is over here on the singleton pattern. For everything else, I normally use regular fields with get and set functions. Personally, that's just the way that I like to code, but that's really just personal preference. So if you do like to use properties, then go ahead and use them. Anyway, so the reason why I like using a property specifically for the singleton pattern is because the implicit implementation allows you to do something really nice. Again, remember the goal with clean code. We want to minimize complexity, and the best way to do that is minimize access. Here, if we set this property and we set it as public, then that means that any other class can both get and set, so anyone else can have both read and write access. So we have the exact same problems that I warned you about when I spoke about why you should not make everything public. And of course, if we make this private, then at that point we kind of lose the purpose of our singleton, since no one else will be able to access this. Basically, we want to be able to access this reference from classes outside of this one. We just don't want those classes to also have write access. Now, thankfully, properties have an excellent thing, which is you can define accessors for here both the get and the set. So we can make the property itself public, which means by default both of these will be public. But then we can also add the accessor over here private, which in turn means that the get will be public, so any other class can get this, but private means that only this class can set it. This way we have the exact level of accessibility that we want. This is the reason why for this specific use case properties are very useful. With just this one line of code, we already have our instance with the perfect level of accessibility. So now that we have this field, to set it, let's make a simple awake. So let's go over here, private void awake, and on awake we just set instance equals this. However, remember that a key point of the singleton pattern is you only have a single instance of something. So in this case, we should never have more than one player. If we do, then something went wrong. So we can add a nice safety feature here. Let's just check if instance, if it is not null, meaning it has already been set to something. If so, then that's an error, something bad happened. So let's do a debug.log error, because this should never happen. So let's say there is more than one player instance. This way we have a nice safety check just in case something goes wrong. Alright, so that's really it for the singleton pattern. We just define a property with a public get and a private set, and on awake we just set the instance. That's it. As you can see, it's super simple. And now for the really useful part. Over here on the selected counter visual, now we can access the singleton instance in a super easy way. Let's make a private void start, and on start we just access the player class, and from the class we can access the static instance, so we can access the singleton, and now we can listen to the onSelectedCounter event. And over here, by default, Visual Studio gives this function the name of the event and also the property. This isn't a very descriptive name, so I like to rename this, so Ctrl-RR, and just rename the instance here. Instead of instance, let's rename it to player. Okay, great. So over here we can listen to this event. However, here is yet another extremely important thing. Note how I made this on start. That is very important. If you do this over here on awake instead of start, and over here on the player, you're also setting the instance on awake. If you do that, basically there is a chance that this code will run before this code. And if that happens, well then this one, the player instance, has not been set yet, so this will be null and it will throw a null reference exception. Now whether this happens or not is actually somewhat random. It depends on the order in which Unity decides to run both these scripts. If Unity decides to run the player first and this one second, if that happens, then there's no problem. But if Unity decides to run this first and then this one, then we have a problem. Let me do a quick test and see if in my case it triggers that error. And yep, in my case it did trigger that error. So here we have a null reference exception. And yep, it is being fired on this line. Now, one solution to this problem is you can tell Unity specifically which order the script should run in. So you can go up here into Edit, then go into the project settings. Then on the left side, you've got something called the script execution order. And basically over here, you can set the order in which all of these scripts run. So if you were to make the player script run before the default time, that would make sure that even though both these scripts are on awake, this one would run before this one. So that would fix that problem. However, you should really only use this approach in the last case possible where there really is no other way. In this case, we do have another better way. Personally, I have a very simple rule that I like to follow that helps solve this issue. As you know, Unity has both an awake and a start. And all of the awakes on all the objects will all run before all of these starts. So the simple rule that I follow is that I use awake for the initialization of that script, and for any external reference, for that I use it on start. So in this case, for initializing the player and setting the instance, that relates to the initialization of the player, so let's do it on awake. Whereas over here on the visual, since here we're going to access the player, which is an external reference, for this one, instead of doing it on awake, let's do it on start. This way we are guaranteed to make sure that this instance has been set. Okay, so with all of that, here we have our instance, so that works great, and we have our event, so that's great. Then here we have our event, and inside we've got our event args, so we can go inside the event args object, and inside we have our selected counter. So all we need to do is just compare which counter this visual belongs to. So let's actually make a field up here. So as usual, let's make a serialized field of type clear counter. So we have this one, and before we go into the editor, just make sure it compiles. Let's comment this out. So now let's go back into the editor. And over here, let's drag the reference. But again, remember, we're working with a prefab. So let's click on open to go inside the prefab. And now whilst inside it, let's select the selected game object and just drag the clear counter reference. Okay, great. Let's go back outside and save the changes. All right. So now here in the code, it's actually very simple. So we just do an if the selected counter matches this clear counter. If so, then we want to show this visual. If not, we want to hide it. So let's also add a reference for that visual. So let's add another serialized field of type game object for the visual game object. Then back in the editor, again, let's go inside the prefab, and on the select, let's drag the child kitchen counter. So drag that one, that is the visual game object. Okay, let's go back, save, and back in the code here, let's make some simple show and hide functions. So private void show and a private void hide. And now on the show, just going to visual game object and call set active. So this enables or disables the game object. So for show, let's set it to true. And for hiding, let's set it back into false. Okay, so now it's super simple. If the selected counter is this counter, then let's show the visual. If it is not, then let's hide the visual. All right, that's it, super simple. Let's test. So here we are, and if I approach that counter, yep, there you go, look at that, the nice selected visual. And if I go into this one, yep, there you go, I can see it. All right, great. So here we added a really nice visual to our selected counter, and more importantly, we learned about the super useful singleton pattern, as well as learning about C# properties, and a very helpful rule for how to avoid code timing issues. So this was a really detailed, really important lecture. If you're feeling confused about anything, go ahead, watch it again, or just post a question in the comments and I'll do my best to help. So with all of this is all great. We have the selected counter and we can see which one is actually being selected. Then by pressing a button, we can actually interact with it. So I can move and interact with any of these counters. But right now, just interacting with them doesn't really do anything. So the next thing we need is to create some proper objects for all of our ingredients, so we can later pick them up and drop them on counters. So let's begin doing that in the next lecture. Hey again, quick intermission. You're past the 15 lecture mark, so congratulations. Looking at my regular course stats, it seems about 80% of people give up by this point, so great job with sticking with it. The difficulty and complexity is increasing over the lectures, so I just want to check in to make sure you're understanding everything. Remember to post in the comments if you need extra clarification on anything, and I'll do my best to answer. Also check the website to see what questions others have asked. And of course, remember this is your learning journey. You're not competing with anyone but yourself. So take your time, rewatch some lectures if you need to, just focus on learning. Okay, let's go to the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to create the kitchen objects like the various ingredients. Okay, so far we have our player, we can walk around, I can approach each of these counters, and I can interact with it. Now the next goal is to create objects the player can pick up and drop when interacting with a clear counter. So let's begin by making the actual objects. So let's create a new empty game object, call this one the tomato. Then again, as usual, let's separate the visual. So in the included assets, let's go inside of it. Then we've got the prefab visuals, and we've got the kitchen objects visuals. And inside we've got all of the ingredients. So let's just find the tomato visual and drag it as a child of the tomato. And again, as usual, make sure to put on position, local position 000. And for the main one, let's put it on a Y of 0 and just push it a little bit off to the side just so we can see. Okay, great. Now this one is obviously not going to exist over here in our world. Instead, we're going to spawn it. So let's make it a prefab. Let's just drag it over here into our prefabs. Okay, there it is. Let's delete it from our scene. And actually on our prefabs, let's make a nice folder to keep things nicely separated. So inside the prefabs, let's make a subfolder. Call it the kitchen objects. Let's put the tomato inside of it. And let's also make another folder for the counters. And let's put the clear counter inside of it. Okay, so everything is nicely organized. All right. Now that we have this, let's go inside our clear counter script. And over here, let's add a simple reference to our prefab. So let's make of type transform, call it the tomato prefab. By the way, here you could make this prefab reference of type game object. Which type you use in this scenario is pretty interchangeable. I talked about those differences in another video. So when using prefabs, using them as transforms or game objects, that's pretty much personal preference. And personally, I just prefer to use them as transforms. Okay, so we have this. Let's just make this a serialized field so we can set it in the editor. And over here in the editor, let's open up, go inside the counter prefab and just drag the tomato reference. Okay, great. Let's go back outside, save. Now back in the code here, when the player interacts with it, let's just spawn it. So let's call instantiate, pass in the tomato prefab. And now here is a good question, which is where exactly do we spawn this? We don't want to spawn on this counter's origin. Remember that the counter, the way we set it up, the origin on the actual object is over there on the bottom. We don't want to spawn the tomato inside the mesh, that would not make sense. Instead, what we want is to spawn up here. So the next question is, okay, so how do we get this point on top of the counter? One approach would be to use a vector3 directly in the code. That would work, but not very usable. So a more designer-friendly method is to simply use an empty game object as a target. So on the counter, let's first go inside our prefab. And over here, let's create an empty game object inside of it. Let's call this the counter top point. Let's make sure to leave this one as empty, so no components, just a transform. And now let's just position it, so let's lift it up by just about enough, so let's make sure we see. So there you go, just about that. So let's put it on position, a Y of 1.3. Alright, so this point is going to be our spawn point. Let's make sure to save the prefab. Then back in the code here, let's add a reference to our point. And for reference, let's also use a transform reference. Call it the counter top point. Okay, now let's just comment this line just so the code compiles so we can drag the reference. Back in the editor, inside the prefab, let's just drag the countertop point reference. Okay, great. So now here, when we call instantiate, let's instantiate it inside the countertop point. So this will spawn the object, so let's say the transform for the tomato transform. And then we go inside this one, and let's just make sure we position it correctly. So let's put it on a local position of vector3.0. So this will put the object exactly on top of our countertop point. Also here, very important, don't make a mistake. Make sure you're modifying the local position and not the global position. Okay, so with this, let's test. Over here in the editor, let's go back, save our prefab, and hit on play. So here we are, let's approach the counter and interact with it. And yep, there you go, it does work. The tomato was indeed spawned. All right, awesome. Okay, so with this, we have pretty much our basics working. We can move up to a counter, we can interact with it and spawn an object. But now let's say that we want to spawn a different object. So let's say now we want to spawn some cheese. First of all, let's make the actual object. So on the tomato, let's press Ctrl D to duplicate this one. Let's rename this to the cheese block and let's go inside of it. Now in here, instead of the tomato visual, let's drag, here it is, the cheese block visual. So let's use this one instead. Okay, there's our nice visual. Let's make sure to save the prefab and go back out. And now let's say that we want this one to spawn a tomato and this one on the left to spawn some cheese. So let's override the prefab and over here drag the cheese block. And now if we hit on play, can go up to this one, and yep, there's a tomato, go up to this one, and yep, there's some cheese. Okay, so it all looks great. But now let's say we want to know what object we just spawned. Like what object is on top of this spawn transform. Just like this in the code, all we have is a transform reference. So with this, the only way to know what type we spawned would be if we had different prefabs for every single object. Then we could compare them one by one and see which one this matches. But then let's say, what if we wanted an actual string for the object? Well, then we would need to add tons of fields for all of these strings for all of the objects. Then what about an icon for each type? Once again, we would need tons of fields, each one for each icon. But if we did it just like that with a bunch of lists, then they would be separated. That's not very good. We should have a proper way of defining our object types and all the data related to them. So this is exactly where scriptable objects come in. These are objects you can create in your project files, which are perfect for anything where you have multiple instances of a type. Like for example, multiple weapons, multiple armors, multiple recipes, or maybe multiple ingredients. As usual, I have a dedicated video on scriptable objects. They are super useful, definitely watch that for more detail. Over here, let's just use them. So the first thing we're going to need is to actually define the type, and we do that in a C# script. So in our scripts folder, let's create a new C# script. Call this the kitchen object SO. Now personally, SO is just what I like to append to my scriptable object definitions, just to make it very clear that it's a scriptable object. However, this is not a requirement, it's just a naming rule that I like to follow. And we're calling this kitchen object because we're going to use this to define any kitchen object we want to interact with. So that's going to be our ingredients, like for example the tomato and cheese, but also things like a plate, and then potentially you could implement things like a frying pan or frying extinguisher or anything like that. So this is going to represent any kind of kitchen object the player can interact with. Okay, so let's make the script, and now let's open it. And over here, okay, first things first is this is not a mono behavior. Instead, let's extend scriptable object. And then technically you can have functions inside a scriptable object, but for now let's just get rid of this, so just an empty class. And over here let's just place whatever fields we need to store whatever data we want. So like I said, first we want a prefab, so let's make a public transform for our prefab. By the way, here note how I am indeed using public. This is pretty much the one exception to the rule. I only use scriptable objects as read-only data containers, I never write to them. So since I follow that rule, I usually make the fields in the scriptable object public. That way I can access them directly without having to make a public getter. But if you want, do feel free to keep following the general rule of not making anything public. You could definitely make this just a regular serialized field and expose with a get function, that would work. Personally, I just find it simpler to make it public, since I know that as a personal rule I will never write to a scriptable object field. Okay, so we have a transform for our prefab. Let's also add a sprite for the icon sprite. And finally, let's just add a simple string for the object name. Alright, so we have our scriptable object definition. We have all of the fields for all of the data we want to store. Now, how do we actually create a scriptable object? For that, let's go up here before the class name, and we're going to add the attribute, so let's add the square brackets. And the attribute is the create asset menu. This takes some optional parameters. Again, I cover them in detail in the dedicated scriptable objects video. For now, let's just leave all the parameters as empty, just use defaults and close the attribute. Okay, so that's it. Let's save this and go back into the editor. And over here, if we go into the project window, click on the plus icon, and right up top, yep, we do see a kitchen object SO. So if we select it, yep, there you go, it creates a brand new object inside of our project files. Let's name this one tomato. And obviously, let's keep our project nice and organized, so we don't want this inside the scripts folder. Instead, let's make a proper folder, so create a new folder, call it our scriptable objects. And then inside, let's put a different folder for each type. So let's make another subfolder, call it the kitchen object SO, and let's place the tomato inside of it. Okay. Now with the tomato selected, we can look in the inspector, and we can see, yep, it does have all of the fields that we defined. Okay, great. So now we can just assign them. So this is the tomato, so let's drag the tomato prefab. For the icon sprite, let's find it. So there are sprites included in the regular assets, so here is the tomato sprite. So it's inside the assets, then inside textures, icons, and we have all the icons. And finally, for the readable name, let's just call it tomato. Alright, so that's it. Here we have a really nice scriptable object containing all the data required for our tomato. Okay, awesome. With that then, we can now go back into our clear counter script. And here, instead of having a field for our tomato prefab, instead of this, let's store a reference of type kitchen object SO, and let's call it kitchen object SO. And then when spawning, let's go inside our scriptable object and just spawn the prefab reference. So this is going to be the kitchen object transform. Then over here in the editor, let's go inside the clear counter and let's assign the tomato kitchen object. Okay, so let's save it and test. So here we are, let's approach, hit, and yep, there you go, it still spawns the tomato. Okay, great. Now let's make another type for our cheese block. So let's create a brand new kitchen object SO, call it the cheese block. And again, let's assign, first of all, the prefab, there it is. Then for the sprite of the cheese block, and finally, this is the cheese block. Okay, so now, for example, let's go into the second one. And on the second counter, let's override and say this one spawn a cheese block. So let's test. So here we are, approach this one. Yep, there's a tomato, this one, and yep, there's some cheese. Okay, great. So everything is working so far. However, the original problem that we're trying to solve, identifying the spawn prefab, we still don't have a solution for that. Basically, when we spawn a prefab, we need to know from which scriptable object this prefab came from. So essentially, what I like to do is just attach some reference to the scriptable object in our prefab. However, again, remember that scriptable objects are not mono behaviors. So if I select the prefab and I try dragging the scriptable object, nope, it does not work. So what we can do is just create a new script. So let's make a brand new C# script. Let's call it kitchen object. Let's attach this to both prefabs, so both the cheese and the block, attach the same one to both of them, and let's open. And over here, very simple, let's just add a serialized field for our kitchen object. So a serialized field of type kitchen object SO for the kitchen object SO. Then let's also make a quick function to expose it. So we're going to return kitchen object SO, get kitchen object SO, and we just return the kitchen object SO. Yep, just like this. So now here in the editor for the tomato, yep, we've got the field. So let's say this one is a tomato, and the cheese block, this one is a cheese block. Now here, obviously, we need to make very, very sure to drag the correct reference to the right scriptable object. If you drag the wrong one, like for example over here on cheese, you would say this one is a tomato. If you did that, then obviously you would get some very weird results. So make sure to check and double check that you drag the right references. Both over here on the prefabs, make sure they are referencing the correct scriptable object. And on the scriptable object itself, make sure they are referencing the correct prefab. Okay, so now if you go here on the clear counter, we spawn our object. Okay, great. Then on this object, we can do get component of type kitchen object. And then we can just ask it to give us the kitchen object SL. So for example, let's do a debug.log on this one. So inside, get the kitchen object SO, and then let's print out the object name. All right, so here we are. Let's interact with this one. And yep, there you go, interacted and spawned a tomato. And on this one, yep, interacted and spawned a cheese block. Okay, awesome. We spawned a transform prefab, and we identified the spawned object is indeed this type of object. All right, so here we'll learn about one of the most powerful Unity features, scriptable objects. These are extremely useful for defining a type and then creating multiple instances of that type with whatever data we want. So that can be some ingredients like we have here, or it could be some weapons, could even be some NPC data, maybe some quest data, and so on. It really is an insanely very useful feature. Definitely go ahead and watch a dedicated video on scriptable objects. Then if you want, you can also watch some more videos where I've used scriptable objects. For example, the Minecraft crafting system using scriptable objects, or the Hydroneer crafting system, which again also uses scriptable objects. Okay, so this is done, it's working great. Now let's continue to the next lecture, where we're going to help the kitchen object know where it belongs and help each counter know what kitchen object is on top of it. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a kitchen object parent, meaning that the kitchen object will know where it is, and the counter will know if something is on it. This is important so that later on we can pick up a kitchen object from one place and drop it in another. Okay, so here we have our player. I can move towards this counter, interact with it, and yep, spawn a tomato. Then on this one, spawn some cheese. Okay, great. But I cannot do anything else. In fact, if I interact a bunch more times, really all I did was just spawn a whole bunch more cheese. So instead, I want to be able to spawn some cheese and then pick it up. So let's think about exactly what that means. We want a kitchen object to essentially be placed on a specific place. Based on the design that we're trying to implement, we're never going to have a kitchen object just randomly strewn around the world. We're not going to have tomatoes all over the floor. Instead, the objects will always need to be placed somewhere, and that somewhere can be either a counter or it can be being held by the player. So essentially that means that each kitchen object is going to have some kind of parent that it's attached to. We're going to make sure the counter knows if there is a kitchen object placed on top of it, and we're also going to make sure the kitchen object itself knows where it is. So first, let's do that logic over here on the counter. So on the clear counter script, let's keep a field for a kitchen object. So just a simple private of type kitchen object. Then when the player interacts with it, by the way, we can get rid of these debug transforms, debug logs, we no longer need them. Okay, so when the player interacts, So if the kitchen object is null, if so, then we're going to spawn it. Then when we spawn it, let's assign it. So this one equals the kitchen object get component of type kitchen object. Okay. So if that one is null, we spawn it and we assign it. And just with this, we should have fixed the issue where we can spawn infinite objects. So over here, I can interact. And now if I interact a bunch more times, and I'll look in the hierarchy inside the clear counter, and I go inside the counter top point. Nope, there's only one tomato. Okay, great. So with this, basically, we made the clear counter know if there's something on top of it. Now let's do the other side. So let's go into the kitchen object and make sure that it knows where it is. So over here on the kitchen object script, let's add a simple field for a counter. So private of type clear counter for the clear counter. And now let's just basically make two functions, one to set it and one to get it. So a public void set clear counter. And we're going to receive a parameter of type clear counter. Okay, great. And then we're going to have a public return a clear counter for the get clear counter. And we're just going to return our clear counter. And on this one, just set this.clearCounter equals this clear counter. All right, so on this function, we're assigning this field, and on this function, we're returning this field. So now back on the counter script, we get the kitchen object reference. So on this one, let's call setClearCounter and pass in this one. And if it is not null, so if there's something on top of this, let's just do a debug.log. Let's go onto the kitchen object and get the clear counter. So we should be able to click once and spawn an object, and click twice, and the second time, we should be able to see the name of this clear counter. All right, so over here, let's approach and click, and yep, it spawned. Now click again, and yep, we've got the message. This one is on the clear counter. Okay, great. So far, so good. So the counter knows if there's a kitchen object on top of it, and the kitchen object itself knows where it is. Now let's add some logic to be able to change a parent counter. So over here on the clear counter script, we basically just need to call the setClearCounter function with a different counter reference. So just for testing, let's add a serialized field for the second counter. So clear counter for the second clear counter. Now we're doing this just for testing, just to make sure the logic works before we come up with a more general system. So just for testing, let's come up with some input. And again, for testing, using the legacy input manager to get something quickly up and running is a great thing. So let's quickly get a button input on the counter. So let's make a private void update. And for testing, we only want the testing to work on one counter. So let's also add up here just a bool testing. And then on update, if we are testing and we have the input.getKeyDown on, let's say, the T key. So if you have that, then we can run some kind of testing code. So let's say, for example, if the kitchen object is not null, so if we have something on top of this kitchen counter, let's go into the kitchen object and call setCounter, and let's pass in the second clear counter. So basically with this, we should be able to interact to spawn an object, and then press the T key, and we should be able to see that object be set to a different parent. So here in the editor, let's just set that. Let's say this one is our main counter. So let's drag a reference to the second one, the second clear counter, drag it, and make this one the testing script. And also just to verify that it worked, over here, let's do a get on the clear counter. All right, so let's test and see. Okay, so here we are. Let's approach this one, interact, and there you go, spawn tomato. And now if I interact again, yep, it says the tomato is on this clear counter. Now if I press the testing key, yep, there you go, the tomato was moved onto the other counter. Okay, so the parent changed, the logic worked. However, obviously we have two big issues. The first one is just the visual. You can see the object is still placed on top of this counter, even though technically now it belongs to this one. And the second issue is that this counter still thinks that it owns this kitchen object. And this other counter does not know that it now owns this object. So we need to sort all of that. First, for the visual, it's actually very simple. Here when spawning, we are spawning it inside the counter top point and then setting the local position to 0. So whenever we move to a different second parent, when we do that, we can just ask that second parent to return the counter top point and move it there. So for that, let's make a function to return that. So public, we're going to return transform. So get the kitchen object follow transform. So this is going to be our counter top point. So let's return the counter top point. Then let's go into the function on the kitchen object when we set the clear counter. So over here on the kitchen object on this function, so we set the clear counter. Then let's modify this transform.parent, go into the new clear counter in order to get the kitchen object follow transform. And again, let's make sure to set the local position back into vector3.0. Okay, so with this, when we set the clear counter to a different one, it should automatically teleport to the other counter. So let's test. So here we are, and first let's interact with this one. There you go, it spawned. Now if I press the testing key, and there you go, it does move visually. Okay, great, so far so good. However, the counters still have the wrong data. By the way, here's a quick Unity tip. On the inspector, you already know that you can only see the public and the serialized fields. However, there is actually a way to look at private fields. On the inspector on the top right, there's these three dots, and if you click on it, over here you can modify it into a debug inspector. And when you go into this one, yep, this one does show all of the private fields. So you can see, for example, on the clear counter, so that's the right one, this one over here, the kitchen object, is indeed assigned. And we can go into the other one, and we can see this one has it as null. So debug inspector is really useful in these kinds of cases. If you want to inspect any kind of private fields, you can go to this and see it. Now let's swap back into the regular inspector. And let's fix that issue by notifying the counters that the object is changed. So over here, basically we have two options. Over here on the clear counter, when we modify the parent, when we tell the kitchen object to go to a new parent, when we do that, we can make the new parent responsible to updating itself, or we can just make the kitchen object itself be the one responsible for notifying the new parent. Both approaches can work. Personally, I think it makes more sense for the kitchen object to handle itself. So we just call this function to set the new parent. And when this happens, basically this kitchen object needs to tell the old parent that it is no longer there and needs to tell the new parent that it is on there. So on the counter, let's make some function to set and get a kitchen object. So over here on the clear counter script, let's go down. Let's make first one to set. So public void set kitchen object and receive a kitchen object. And just do this dot kitchen object equals this kitchen object. Okay, great. Then let's make a getter. So public return a kitchen object, get the kitchen object, and just return this kitchen object. Okay. Then let's also make one just to clear it. So public void clear kitchen object. And this one just sets the kitchen object into null. And finally, just a nice simple function to test if this counter has anything on top. So just a public bool has kitchen object. And over here we just return if the kitchen object is not null. Okay, so some four very simple functions. Now if we go into our kitchen object script, over here when we tell it to change the parent, let's first go into the current parent and clear it. So let's first of all do a quick test for null. So if this .clear counter, which is the current parent, so if this one is not null, then we go into the current parent, so the clear counter, and we tell it to clear the kitchen object. And then we go into the new parent, and we tell new parent to set the kitchen object, and the kitchen object is this one. Now here be very, very important, don't make the mistake of clearing the wrong counter. Keep in mind that over here, this .clear counter, this refers to the previous clear counter, whereas the one in the parameter, this is the one, this is the new one. So make sure you clear the kitchen object from the previous clear counter before you assign it, and then you set it on the new clear counter. So be very, very careful here. Make sure you don't make mistakes between the quote-unquote old clear counter and the new clear counter. Okay, so that's it. Basically, we have this function to set the new clear counter, so set the new parent. We clear the kitchen object from the old clear counter, we add it to the new one, and we update the visual. Now, we can also add some nice safety checks here just to make sure we never make a mistake. The kitchen object should never be set to a parent that is already holding something. So before we set the kitchen object, before we do that, let's make sure that one is empty. So over here, just do an if the clear counter, so that's a new one. If this one has a kitchen object, then it already has something on there. This should never ever happen, so let's do a debug.log error and say counter already has a kitchen object. We're going to eventually add tests to make sure that this never ever happens, but having the error here will be helpful just in case we miss something. So if it has a kitchen object, we're going to fire an error, but this should never happen, so we just set the error, update the visual, and so on. Okay, so finally, let's just go over here into the clear counter script. And down here, we have the interact action. So we instantiate the kitchen object. We're currently repositioning it, and then we're setting this field, assigning it to this one. Now we made the kitchen object responsible for doing all that, for modifying the position and for setting the field, so we don't need to do this. Instead, we really just need to go and get the component of that, and just pass in set clear counter, and pass in as this one. So we no longer need all of this, now our code is much more simple. Also importantly, up here we were previously setting the clear counter and then doing a debug.log, but when we set it to the new one, that is actually going to clear this field, so if we leave this, then this is going to throw a null reference exception, so let's just get rid of this log here, we no longer need it. Okay, so let's test and see if all of our logic is working. Alright, so here we are, let's go to this one, interact to spawn it, okay, great. And once again, we can look in the debug inspector, so let's put it on debug, look at this clear counter, so that's the right one, and yep, there you go, it does have the kitchen object, and if we look in the other one, yep, this one has null, okay, great. Now if I press the testing key, yep, visually it did change, and if we look at the counter, so if we look at the old one, so that's the right one, this one is at null, okay, that's great, correct. And if we look at the new one, yep, this one does have the reference. Alright, awesome. So now that we are correctly changing the kitchen object parent, for example, we can now interact again with this one, and yep, it does spawn a brand new one. And of course, if we try moving it to the other one, then we should have our error as intended. This one is currently already occupied with kitchen object, so we should not be able to drop something on there. But if I press the testing key, yep, there you go, nice error, okay, so that's great. We're basically going to fix this error later on when we add checks to make sure the object can only be spawned when it can be spawned. But for now, all of our basic logic is working. We can spawn an object and change the parent. Alright, so with that, here we have added a really important feature to our game, that is the ability to know where a kitchen object is. Now the next step is to enable the player to be able to pick it up and drop it somewhere, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to enable the player to pick up a kitchen object, and in doing so we're going to learn about another awesome C# feature called interfaces. Okay, so right now with our game I can already move the player, I can approach a counter, interact with it to spawn an object, and with the testing key I can move it to a different parent. So all of that logic is working, now let's make it work actually with the player. Let's say when we interact once we want to spawn it, and if there's an object already on top of it and I interact again, then I want to give it to the player. Okay, so here on the clear counter script we've got our interact function, and in order to make that work we need to have a reference to the player, so let's just pass it in over here as an argument for our interaction, so just pass in the player reference. Now over here, let's do the logic that I said. So if the kitchen object is null, so if there's nothing here, then let's spawn it. Okay, great. But if there is something, then let's give the object to the player. So how we change the object parent is just like what we did up here. So let's go into that one, set the clear counter, and pass in the player reference. Except, of course, this obviously does not work. The parameter on this function is supposed to be of clear counter. It does not work with the type of player. Basically, all the logic that we built for setting the parent and changing the parent, this whole thing only works with a counter, so it does not work with any other type, so we cannot set the player as a parent. Now, to solve this problem is exactly where C# interfaces come in. Again, I have a video going through them in detail, definitely watch it to learn everything about interfaces. Basically what it is a contract. You define some functions in the interface, and then any type can implement that interface, and you can write some code that works with the interface, which in turn means that the code will work with any type as long as it implements that interface. So in this specific example, we're going to make an interface to represent a kitchen object parent. Then we're going to implement that interface on both the counter and the player, and that way both of them won't be able to be parents of a kitchen object. So let's do exactly that. Now the first thing we do to define an interface is let's make a C# script. So let's right click, create new C# script. And now the standard is to start interface names with the capital I and then the name. So in this case, let's name it I kitchen object parent. And let's open it. Okay, so now to make an interface, first of all, this does not extend MonoBehavior. Nope. And secondly, this is not a class. Instead, this is an interface. Now, like I said, an interface is essentially a contract where each class that implements that interface must follow that contract. What that really means is that you can define a bunch of functions here. By the way, quick note, you can also define properties, but not fields. I cover all of that in the dedicated interface video. But for now, here we just want some functions. Like for example, let's just put all of the parent functions that we made previously on the counter. So over here on the clear counter, a while ago we made all of these functions that we needed to make it work as a kitchen object parent. So we got the transform, set kitchen object, get it, clear it, and has it. So let's just copy all of this and paste it over here on the interface. However, one important note is on the interfaces, you don't actually include any function implementation. The implementation is up to the class that implements this interface. Although again, I should also point out another quick note, as of C#7 you can include a default implementation, but that's for more advanced use cases. So for here, let's just use the basic and not apply any default implementation right here. So we just define the function and put a semicolon. So just like this, just the function definition with the exact signature. So just like this. Okay, so now with that, we have defined our interface and all of the functions that we wanted to have. With this, now let's go onto the counter script. So over here on the clear counter script, over here, let's implement the interface. And the way we do that is pretty much exactly the same as by extending a class. So over here, we are already extending MonoBehavior. Then let's set a comment, and let's say we are also implementing the iKitchenObjectParent interface. So right now, you might be wondering, so is this pretty much the same thing as extending a base class? And kind of, except for one huge difference. When extending a base class, you can only have a single base class. Like for example, over here we have MonoBehavior. You cannot extend multiple base classes. There can only be one. However, when it comes to interfaces, you can implement as many interfaces as you want. So over here we have defined our interface. And right now we don't even have any errors. That's because we already implemented pretty much all of the exact functions. Also, Visual Studio has a really nice helpful icon over here on the left side. It is basically saying that this function, this implementation is based on the interface. But let's see what happens if I decide to comment out these functions. So if I comment out all of this, and if there we go, over here we have an error. It is telling us that this class does not implement the members for the interface. Like I said, an interface is like a contract, so you must write all of the functions included in the interface. So we must implement these, so let's get rid of the comments. Okay. With this, our interface is perfectly working over here on the clear counter. Now let's just go into the kitchen object over here on this script. For now, we're still working with the type clear counter. So let's just refactor this to, instead of working with a clear counter, let's make it work with a kitchen object parent. So let's just change this from type that to kitchen object parent. Let's also rename this. So let's use Ctrl+RR for the kitchen object parent. Then we got a function to return the kitchen object. Okay, that's good. For this one, instead of set clear counter, let's once again rename this to set kitchen object parent. And inside, again, we receive of type iKitchen object parent. Then let's also rename the parameter to kitchen object parent. Okay, so all the names here I have changed. Okay, they're all correct. We set it, we assign it. Over here instead of counter, let's say kitchen object parent already has that. So just like this. And finally down here, let's return iKitchen object parent and rename this to get kitchen object parent. And we return that. Alright, so we have changed everything. I can even do Ctrl+F to search for a counter, and nope, there's no instance of any counter. So all of this code has now been rewritten to work with a kitchen object parent. So like this, everything should be working exactly the same as previously. We have no errors here. And over here on the clear counter, we just have this error on the player. Let's fix this in a little bit. For now, let's just comment it. Let's just test it out to see if everything still works exactly the same as previously. Also, one final thing, since we modified the interact function over here on the player class, when we have the interact, we just need to pass in this reference. Okay, so let's test. Alright, so here we are. Let's approach this one, interact. Yep, there it is. Now let me press the testing key, and yep, there you go, it does move. Okay, so everything is still working exactly the same as previously. Once again, another successful refactoring. Now here comes the magical moment. So right now, again, everything is still working exactly the same as previously, so we can only have counters as parents. But now let's go over here onto the player script. And over here, let's also implement the same interface. So let's implement the iKitchen object parent. And again, as usual, we have our error, so we need to implement this. Also again, Visual Studio is very helpful, so we can click on the light bulb icon, and let's say implement the interface. And if we scroll down here, it will automatically create all of these functions. So let's just actually implement them. So for implementing this interface, the code is really going to be exactly the same. So let's go up here into the clear counter. Let's go down, find all of these functions. Let's copy them, and on the player, let's paste them down here at the bottom. So we just need to also pick up the kitchen object as well as a reference to the top point. So over here on the clear counter, let's just grab both those. So let's just grab the kitchen object, so go into the player, and over here, let's add a field for the kitchen object. And finally, let's add another one for the counter top point. So over here, a serialized field for the counter top point. Except obviously the player is not a counter, so this name makes no sense on the player. So let's just quickly rename this and call it kitchen object hold point. Okay, here we have our new name. We've got the kitchen object, and down here, all of our functions, they're all working, no errors. All right, now let's just assign this in the editor. So over here, let's just go into our player. There's the player script and requires a reference to the kitchen object hold point. So for that, let's do it just like we did for the counterpoint. So inside the player, let's create an empty game object. Call it the kitchen object hold point. And now basically let's just position it just slightly in front of the player. So let's put it on a X of 0, on a Y of 1.3, and on a Z of 1. So there you go, just ahead, that's where the player is going to be holding the objects. Finally, over here on the player, let's just drag that reference. Okay, so far so good. Also one note here, like I mentioned previously, in order to implement the interface, it requires you to write the function code. Basically what this means is that different objects can implement the exact same interface whilst having different implementations. So for example, over here on the player, when setting the kitchen object, perhaps over here you could play some kind of item grab animation, or maybe when clearing a kitchen object you could do some kind of logging. The only thing that needs to match perfectly is just the function signature. And the function signature, that means the return type, as well as the name and any parameters. The implementation itself, that is up to the class that wants to implement that interface. But in this case, we want it to behave pretty much exactly the same way, so like this it should be working. So we can now go back here onto the clear counter script, and okay, we have our interaction, alright, great. So if there's nothing, we're going to spawn it, and if there is something on top of it, we want to give it to the player. So now let's go into the kitchen object, and call the function setKitchenObjectParent and pass in the player reference. And that's it, no errors, because again, this takes a parameter of type kitchenObjectParent and the player does implement that interface, so that's all valid. Now with this, let's test and see if our code is working. Alright, so here we are, and let's interact with this counter, and there you go, the object has been spawned. And now if I interact again, yep, there you go, look at that, the player picked up the object. And since our logic is using a transform hold point as the parent, the player is automatically carrying this tomato. Alright, awesome, so this is really great. Now over here on the counter, we no longer need all of this testing code. We now have the ability to actually pick up objects from the player. So let's get rid of all this so we don't need this testing code, don't need a reference to the second player counter or the testing. Okay, great. So here you can see the power of interfaces. By just implementing the interface, we can now place an item anywhere we want, and importantly, on any type we want. So the counter can hold a kitchen object, the player can also hold it. We could make a dog character and make it hold a kitchen object. We could make a vehicle hold it, or anything. Again, interfaces are really awesome, one of the best C# features. Definitely go ahead, pause this course for now and watch a dedicated video on them. You should be very familiar with interfaces. They will help you in making all kinds of systems and games. If you want to see a clear example of the power of interface, you can go watch my How to Interact with NPCs video. That video takes advantage of interface to make sure that the player can interact with any kind of object. Alright, so thanks to interface, we can now change the parent of the kitchen object and put it on either a counter or the player. Now in the next lecture, let's make a proper different counter type. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a different counter type from where we can grab some ingredients. Okay, so far here we have our character working and we have an empty counter, and by interacting with it we can spawn an object. But obviously that's not the behavior we want in the final game. We want different counter types that do different things. The clear counter should only be used as a place for putting down and grabbing objects. It should not spawn anything. So let's build a new counter type. And for that, one option is to make a brand new prefab and build it all from scratch. Another option is we can duplicate this counter and change a bunch of things. Or there's a third option that was added in recent Unity versions. You can now have what is called prefab variants, meaning that we can have a base counter and then we can make variants for all the types. So let's do exactly that to learn about prefab variants. Now first, let's duplicate this one just so we don't lose any changes. Let's rename this prefab to _base counter. Now I like to add an underscore just so that the base prefab is on top, since this window is sorted alphabetically. Now let's go inside the base counter. Let's go into the scene view, so here it is. And basically over here, we only want to have all of the things that all of the counters will have. So all the counters will have a box collider, all with the same shape, so that's good. They will also all have a counter top point. However, for the visual, different counters will have different visuals, so let's get rid of this. Same thing for the selected, let's get rid of this. And on the actual object, different counters will have different scripts. So let's also get rid of this. Okay, so that's it, this is the base counter. It only has all of the things that every single counter will have. So let's go ahead, save this prefab, go back outside. And now let's right click on the base counter and go into create. And over here, let's scroll down and find the prefab variant. Now let's name this the clear counter, except obviously we can't have two different names. So let's put this one into backup. We're going to get rid of this one in a little bit. So on the variant, let's name it clear counter. Let's open up this variant. And now here, let's add everything just like we had on the old clear counter. So since it's going to be exact, let's actually go inside the backup one. So here, let's just copy the visual and the selected. So let's copy this. Go back inside the clear counter variant, and over here let's paste it, so Ctrl V. So there it is, the selected and the visual. Finally, just a script, so over here let's add the clear counter script. And now let's just drag the references, so the kitchen object, we're actually going to remove this in a little bit, but for now let's assign it. The counter top point, let's drag it, and on the selected we also need to drag the kitchen counter reference. Okay, so here is our clear counter as a variant of the base counter. So let's go ahead, save this, and go back outside. And now we can finally delete the old prefab of the clear counter, so let's go ahead and delete this. And of course, over here on the scene, we've got some broken prefabs, so let's get rid of both these. And let's drop the clear counter variant, so let's drop it, place it over here. So let's put it on X of 0, Y of 0, and Z of 3.5. Okay, so that's the clear counter. Let's just put another one to the side, and perfectly on the side, so on an X of minus 1.5. Okay, now we can begin making our container counter. So for that, once again, let's make a variant. So right click on the base counter, go into create, and let's create a prefab variant. Call this the container counter, and let's go inside of it. Now here, first thing we need is the visual. So let's go inside our assets. We've got the prefab visuals. Inside we have the counters visuals, and let's find the container counter. So let's drag it inside. Again, for the local position, make sure it's all on 0, 0, 0. Okay, great. Then we need to make the selected, so let's duplicate this visual. Let's rename this to selected. Let's go inside on all of these. Then let's modify the material for the selected material. So let's click on the circle icon and select the counter selected material. Okay, we've got our nice little ghost icon. And just like we did previously, let's start with these disabled. So all of these game objects disabled, so they are hidden. And on the selected, let's make sure the scale is 1% bigger, so 1.01. Also on the selected, this one does not need an animator, so let's get rid of this. Now let's add the selected counter visual. And obviously for this one, we're eventually going to need to refactor it to support multiple visual objects. As you can see, this selected has multiple. But for now, just make sure that it works. Let's just drag just the first one. Okay, great. So our container counter has been built. The only thing that we need is the main logic script, so let's do that. Let's go into our scripts folder. Let's create a brand new C# script. Name it the container counter, and let's select the main game object, attach a script, and let's open it. Alright, so now here let's first think what we want. For this counter, we want the player to interact with it, and when it does, we want to spawn an ingredient and give it to the player. So that means that we're going to want pretty much the exact same behavior that we made over here on the clear counter. So when the player interacts, we spawn and we give it to the player. So let's actually copy all of this code. Let's go into the container counter, and over here, let's paste this. We just need to grab the references to the kitchen object and the kitchen object SO. So again, just like we did on the container counter, let's copy all of these references. And over here, let's paste all of them. And of course, here we have an error. In order for this to work, this needs to implement our interface. So let's do exactly that. So let's implement the iKitchen object parent. And back in the clear counter, let's just copy the exact same code. So all of these functions, let's just copy them. And on the container counter, just paste them. Okay, great. So we don't have any more errors here, so everything should work. We should be able to interact with the container counter, and we should be able to see an object being spawned on top of it. Over here in the editor, let's just make sure to assign it. So let's assign a default kitchen object. So let's say a tomato, and the counter top point. Let's drag the reference. And okay, everything else should be working. So over here on the selected, we've got the visual game object, and on the container counter, we've got this. Okay, great. So let's go outside into scene view. And over here, let's just place some container counters. So let's drag one up there. Let's place it on an X of 1.5, on a Y of 0, and Z of 3.5. And let's also place another one down here. So let's rotate it to face it upwards. Okay, so on position 0, 0, minus 5. Okay, great. And let's make them spawn different things. So on this one up here, let's actually spawn a cheese block. And on this one down here, let's spawn a tomato. So let's also modify the icon here. So from cheese block, and let's put a tomato icon. So here it is. Okay, we've got 2 counters and 2 clear counters, so let's test. So here we are, and if I approach the container counter and I press the interact button, and nope, nothing happened. We cannot interact with it at all. Even the selection visual, even that one is broken. So as I approach, nope, the visual is not showing up. Now the reason for this is actually pretty obvious. If we go over here on the player script, down here when we're handling our interactions, so let's go into the handle interactions function. Over here we are doing a raycast, and we are trying to get component of type clear counter. So basically we're not doing anything if that object has a container counter instead of a clear counter. So again, we have a similar issue to the one that we had in the object parent logic. Basically we have 2 types, a clear counter and a container counter, and we want the player to be able to interact with both of them. So as a solution for this exact same problem, we could also implement an interface just like we did. That would work, that would enable the player to interact with multiple counters. But in this case, since the counters are all very similar, very related objects, they're all going to be kitchen counters as opposed to object parents where the player and the counter are completely different. In this case, since they are all very similar, a better approach is actually to use inheritance. Now here I should point out that inheritance is one of those things that is simultaneously very powerful but also very dangerous. Usually beginners get really excited when they first hear about inheritance, but after gaining some experience they start to see the massive downsides. One funny joke about it is, let's say you want to write some code that all it needs is a banana class, but because of messy inheritance you end up with a monkey and the entire jungle behind it. Basically the banana extends a monkey, which extends a tree, which extends a jungle, and so on. So you just want a small thing, but because of a complex inheritance you end up picking up a huge object. So all of that to say, inheritance is something you must use very, very carefully. It's a powerful tool, definitely, but you need to make sure to absolutely use it in the right approach for the problem you're trying to solve. Now in this case, like I said, since all of the counters are going to be very closely related, in this case it does make sense. And of course in the future, if that does change, we can always refactor. If you're a beginner, definitely go ahead and research a bit more on C# inheritance, the pros and cons. I don't have any dedicated video on that topic myself, but if you search, I'm sure you'll find tons of content. Again, it's a very powerful but also very dangerous tool, so definitely use it wisely. Over here, let's make sure we're wise, so let's use it. First thing we need to do is define the base counter class, so let's create a new C# script. Let's call it the base counter. So over here on the script, let's get rid of the functions. We don't want any default functions. And let's also make sure that we do extend mono behavior. We do want that. We still want to use this as a component. So let's leave the script just like this. Let's save it. Then let's go over here into the clear counter script. And on this one, instead of extending mono behavior, let's extend the base counter. Okay, that's it. That's the only change. And now let's go into the container counter. And over here, same thing. Let's extend the base counter instead of mono behavior. So now both these counters extend the exact same base counter script. So now if we go into the player script, so here we are on the player script, and on the handle interactions function, over here instead of trying to get a component of type clear counter, let's try to get the component of type base counter. So let's also rename this, so Ctrl+RR to rename this to base counter. And of course we need to rename all these references that expect a clear counter instead of a base counter. So over here for the selected counter, let's modify the type to base counter. Then also up here, when we've got the event args, let's modify the type, okay? So over here we have the interactor. Let's leave this for a bit. Let's go down and let's fix this issue. So let's go down into that function to set the selected counter. Instead of this type, let's receive a base counter. Okay, so all of these errors have been solved. There's only one left, and it's this one, the interact. We see this error because obviously the base class does not have any kind of interact method. So let's add that. Now for adding methods to a base class, it's actually very simple. It's really just like any other method. So first the accessor. For the interact, we want the player to be able to access it, so let's make it public. And also since we're talking about inheritance, I should probably mention the other accessor. Now you already know about public and you also already know about private, but there's another one you might not know, which is called protected. Basically, this one means that whatever function we define with this accessor, it is going to be accessible to this class and any class that extends it. So for example, if we had a function that was protected, the clear counter could call this function because it does extend this base class. However, the player would not be able to call this because it is protected. Now in our case, for the interact action, we do want the player to call it, so let's make it public just like we had previously. Then another keyword. For every function that we want the child classes to be able to implement in their own way, we can define it as virtual. And finally, the function signature as normal. So for the interact, we made a return void, call it interact, and we received a player argument. Okay, so that's it. That's our basic signature. For the implementation, let's leave it empty over here on the base counter. So by default, it's not going to do anything. In the game design that we're building, we're never actually going to end up with anything like this. So if we want, for safety, we can just add a debug.log error to say just base counter.interact, because this should never be triggered. Also, I should point out, for a more advanced method, instead of making it virtual, you could make it abstract. And basically what that does is that forces all of the classes to implement their own implementation. So you would make this abstract and just put it just like this, as if this were an interface. But in doing so, you would also need to define the base counter as abstract and so on. So basically this is a more advanced method, so don't worry about it for now. Let's keep it a bit more simple. So let's make it just virtual void interact. Okay, great. So we have this, let's save this. And now if we go on the clear counter, over here on the interact, notice how we have a green squiggle line. Basically this is a warning, it's telling us that we are hiding the base function. Now in reality we don't want to hide it, instead we want to override it. So before the void, before the return type, we just add the keyword override. And yep, this will now override the base function. So when the player interacts with an object of type base counter, and that object is actually a clear counter, when the player calls the interact function, instead of running this code, it's actually going to run this code. Now let's do the same thing on the container counter. So over here, let's also add the keyword override to override the base function. Okay, great. So we have no errors here. And on the player, we also don't have any more errors since that one does now implement the interact function. So with this, let's test and everything should still be working. So over here, let's approach the interact counter and let's interact with it. And yep, it does work. It spawned some cheese. And down here, yep, it spawned a tomato. And then if we go onto the empty counter and interact, and yep, it still works. Okay, so here we added the ability to interact with two different counter types. All right, great. Now note how the selected logic isn't really working well. You can see the container counters, they are both selected, even though the player is not looking at them. And actually, if I approach it, then it actually becomes deselected. Basically, the reason for that is because the selected script, that one is still referencing the clear counter instead of the base counter. So right now, it's only being selected when the selected counter is null. So that is why as I approach, it actually hides itself. So let's fix this. Let's go inside the container counter prefab, and inside we've got the selected. And yep, over there we have a reference to that. So let's open up this script. And over here, all we need to do is just modify this type. So let's make it of type base counter. And let's rename this to base counter. Okay, that's the only change we need. And by the way, since we're here, let's also fix the other issue. The issue we had where we need to support more than one visual game object. So instead of having a field of type just game object, let's receive a game object array. So let's modify this to game object array. And then down here on the show hide is actually very simple. So let's just do a for each game object for the visual game object. In the visual game object array, we go inside, set it to true, and on this one we set it to false. Okay, that's it, super simple. Now let's just update the prefabs. So first over here on the container counter, let's drag the container counter reference as the base counter. Okay, great. And for the visuals, let's just drag all of them. So let's drag the counter solid, drag it on top, then the counter hole, drag it on top, then the single door, drag it, and the black, drag it. And also, by the way, over here on this counter, this one actually has an object sprite. This is the actual sprite in there, but for the selected, we really don't want that. So if I enable this game object, here we've got the object sprite. Let's actually delete this. We don't need the actual icon sprite to be highlighted, so let's leave it just like this. So we only have these 4 objects, and all 4 of them are on the list. Okay, that's great. So all the references in here, they're all working perfectly. So let's go back outside, let's save the prefab, let's go inside the empty clear counter. And on this one, same thing, on the selected, let's drag the insider reference. And for the base counter, let's also drag that reference. Okay, so let's go outside, save it, and let's test. And now let's see if the selected works. So as I approach this one, yep, it works, and on this one, yep, it works, and down here, yep, it works. All right, awesome. So we can interact and we can highlight our selection. Okay, everything is working great. So now that all of the code is working, we can inspect the code to see if we can refactor anything. We can see, for example, if there's any kind of common logic that all of the counters share that we should probably write in the base counter. And you can see right away that both the clear counter and the container counter, both of them implement the kitchen object parent interface. That behavior is something that all of the counters will share. So instead of defining it on each counter itself, let's actually do it on the base class instead. So let's get rid of the interface implementation here, and also on the container counter, let's get rid of that. Instead on the base counter, let's implement that one. So I kitchen object parent. And for the functions, let's do the same thing. So let's cut this one from here and let's paste it on the base counter. So okay, now we need these 2 points. So let's go ahead, copy all of this. Let's go into the base counter, paste it. Except for the base one doesn't need a kitchen object SO, so just the counter top point and the kitchen object. Okay, so there are no errors on this one. Let's go into the container. Let's get rid of the kitchen object and the counter top point. Okay, great. Now we see an error, but before we worry about that, let's actually go into the clear counter and let's do the same thing. So let's get rid of this, and down here get rid of all these functions. Okay, so now the counter scripts are much more simple. All of the common code is now written directly on the base counter. Now for solving this, the container counter needs to know if there's a kitchen object on top of it. So now here we have an interesting question with 2 possible approaches. Basically we need access to this object. So one approach would be to make this protected. Like I said, protected means that any classes that extend this base counter class, any of those classes can then modify that field. So like this, yep, there's no more errors. That's one approach. And the other approach is to instead keep this one as private. And whenever we want to interact with it, we simply interact through these functions. Both approaches can work, and when in doubt, as usual, you should probably go with the more limited option. So let's leave it as private and work with these functions instead. Over here on the container counter, instead of testing if the kitchen object is null, let's just test has kitchen object. So if it does not have a kitchen object, then we're going to spawn it. And for spawning over here, we could grab the actual transform follow. So this one up here, we could call this function to get it. Or since that is actually going to be handled automatically when we call this function to set the parent, then let's actually not use this at all. So we just spawn it and set the kitchen object parent. Okay, great. So now let's just look at the clear counter. For this one, like I said, it's not really meant to spawn anything. So let's actually remove all of this code. This one is only going to serve to pick up and drop items. We're going to handle that in the next lecture. But for now, let's just go back into the container counter. And let's do the proper logic that I mentioned in the beginning. Basically on this one, we want to spawn the object and we want to immediately give it to the player. So when we call setKitchenObjectParent, instead of passing in this, let's pass in the player reference. And that's really it. For the container counter, this is all we're going to do. So the player interacts and it spawns an object and gives it to the player. Okay, so that's it with this. As you can see, the code for all of our counters is much more simplified. So basically it only handles the logic related to that specific counter. Everything else is on the base counter. So let's test this. So here we are, and if I approach the counter and interact, and yep, there you go, spawn some cheese and gave it to the player. Okay, great. Now, just for fun, when I made these assets, I actually included a nice animation. So if you go inside the container counter, over here on the visual, note how this already has an animator with an animator controller attached to it. You can double click to open it up. And over here you can see it's very simple. Basically just has 2 animations. One is the container close and one is the container opening and closing. These transitions are basically triggered by this parameter. This is a trigger parameter. So when triggers goes into the open close, and when this one ends goes back into close. So let's just quickly add these nice animations. However, again, as usual, let's make sure to write some good clean code. So let's not add the visual over here on the logic script. Instead, let's make a proper new script. Over here, let's create a new C# script. Call this the container counter visual. Okay, now we want to attach this only to the visual game object, so only this one let's attach, okay. And over here, the first thing we need is to get the animator. So let's store a field for the animator. And since it's on the exact same object, we can just make an awake and get component of type animator. And we just assign this field, okay. So with this, we have the animator. Now we just need to know when we should play the animation. So let's go over here on the container counter script, and basically let's make an event that we're going to fire when the player grabs an object. So let's make a public event of type, let's stick with the standard, so let's use event handler inside using system, okay. Let's name this on player grabbed object. And then down here, when the player interacts and gets an object, let's fire off this event. So invoke, let's invoke with this an event args.empty. Okay, so we are firing off this event. And over here on the visual, first we need the field for the container counter, so let's add it up here. Let's add a serialized field of type container counter. Okay, we have this field. Now let's listen to the event. But again, we're accessing an external reference, so let's make sure to do it on start and not on awake. So let's go into this one and listen to the onPlayerGrabbedObject event. Okay, so here we have the event, and it's over here that we want to access the animator and call setTrigger in order to play the animation. Again, when working with animator parameters, sadly we do need to use strings. There's no way around that, but at least we can make it a bit more clean by defining a constant. So up here, a private const string, call it open close, and let's make sure to use the exact same parameter name, so open close. And then down here on the setTrigger, let's call this trigger. Okay, so that's it, some very simple visual logic. And now over here inside the prefab, all we need is to drag the container counter reference, so let's drag it. Also make sure that it has the animator and the animator controller. So with that, everything should already be set up. So let's go back into the scenes, save the changes, and let's hit on play. So here we are, and if I go towards the tomato and interact, and if there I go, it plays a nice little animation. Alright, awesome. Okay, so here we created a brand new counter type, and we refactored our interact code to be able to interact with any counter type. The player can interact with the container counter to pick up an object. Now, the next obvious thing that we need is to enable the player to drop an object on the clear counter, so let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to enable the player to pick up and drop objects. Okay, so we already have the player working. I can approach this container counter, interact with it, and yep, the player picks up something. Now that's left is being able to approach a clear counter and being able to drop this object, so let's do that. Let's go over here on the clear counter script. And when we interact with it, we're going to do a bit of logic. First, let's just check if this counter is empty, meaning if there's no kitchen object on it. So let's test if has kitchen object or if not. So let's say if we don't have a kitchen object, then there is no kitchen object here. And if not, then there is a kitchen object here. Okay, these are the two valid options. So if there is nothing here, then let's check the player itself. So we go into the player and we can ask the same question. So has kitchen object. So if the player is carrying something, so over here the player is carrying something. If so, then basically we just want to drop that object from the player and drop it in here. So that's very simple. We just go into the player, we get the kitchen object that the player is holding, and we just modify the kitchen object parent onto this object. Alright, so that's it. Just with this, it should already be working. Let's do a quick test before we handle the rest of the interactions. Okay, so here moving the player, and if I just interact with the clear counter, and nope, nothing happens. Okay, great. Since the player is not carrying anything, nope, nothing happens. Alright, great. Now let's pick up something from the container counter. Okay, so now the player is carrying a tomato, approach the clear counter, press the button, and yep, there you go, there it is. Alright, awesome, everything worked. Now this is an excellent point to know just how easy this was to implement, and the reason why it was so easy was because we focused hard on writing some good clean code for how the object and the parent system works. Because we took some time to think about that, it was now very easy to implement this brand new action. So this is a very, very clear example of the power of writing good clean code. Okay, so with that now let's implement the rest. So over here there's no kitchen object here and the player is carrying something, but if not we've got the else, so player has nothing. So if the player doesn't have anything, so let's not do anything. So player not carrying anything. So those are all the possible states up there. And then down here, if there is a kitchen object on this clear counter. If so, then let's check if the player has a kitchen object. So in this, the player is carrying something. And if not, then the player is not carrying anything. So basically, if there is a kitchen object here and the player is carrying something, if so, then we don't want to do anything since we can't give the player two items. However, if there is a kitchen object here and the player is not carrying anything, then we want to give it to the player. So let's just get the kitchen object, the one that is on this clear counter. And let's do the exact same thing. So set the parent and set the parent onto the player. Okay, so that's it. As you can see, some very simple logic. So let's test. Okay, here we are. And if we interact, nope, nothing happens. Okay, great. Now pick up a tomato, go there, drop it. Yep, there it is. Now if I interact again, yep, there you go. I picked it up again. So I can go somewhere, pick it up, drop it, and everything works perfectly. All right, awesome. Now the last thing that we need to fix is the container counter. Right now it's giving out an object every time, even if the player has something. So if I pick up, yep, it works. Now if I pick up again, there you go, we've got our nice helpful error. This should never happen. So let's set some nice checks. So over here on the container counter, okay, we have our interaction. And before we spawn anything, let's just see if the player can pick up something. So once again, very simple. Let's just go into the player and we check, does the player have a kitchen object? If so, we're not going to give it anything. But if the player does not have a kitchen object, then yep, the player picks it up and we give it the object. Okay, so that's it. It's this simple. Let's test. So here we are. Let's pick up some cheese. Okay, great. Now pick up another one. And nope, nothing happens. Okay, great. We're already carrying something, so we cannot drop anything. Now drop it in there. Now pick up a tomato. And yep, it works. I can pick it up, drop it, and yep, everything works. Okay, great. Let's just do one more thing. Over here, the container counter is spawning the object. And the object is the one that we assigned. So over here in scene view, we've got the container counter. This one is placed on the scene, and we made an override to spawn a cheese block. Technically, we could keep doing this. Pretty much just duplicate objects, modify the sprite, modify over here the kitchen object. That would work. But another better approach would be to simply make some prefab variants. And yep, that does work. You can make a variant of a variant. So let's do exactly that. Over here on the container counter, let's right click, go into create, let's create another prefab variant. And let's say container counter, this one will be the tomato. Now let's go inside the prefab. And over here, make sure it has the kitchen object for tomato. Okay, great. And over there on the sprite. So let's find the object sprite and choose the tomato sprite. So there you go, this one. Okay, let's exit and save. All right, now once again, let's right click on the container and let's make yet another one. This is going to be the one for the cheese block. So let's go inside of it and over here, modify it for the cheese block. And inside the actual visual, let's modify the sprite, and it's actually down, so the cheese block. Okay, great. Let's go back outside. And since we're here doing this, let's make all of the other grabbable objects from the containers. So let's first make the kitchen object SO. So let's go over here. We can right click, go into create new kitchen object SO. Let's make one for the bread. Then let's duplicate this one. We're going to have a cabbage. And finally, we're going to have the meat patty uncooked. All right, so now let's make sure to assign all the data for all these scriptable objects. First, we need to make the actual kitchen object. So let's duplicate tomato, name this one bread. Let's go inside of it. And first for the kitchen object SO, let's make sure to drag the correct one. Okay, there's the bread. And for the visual, this one is not a tomato. So let's go inside our visual assets, inside the prefab visuals. Let's pick up the bread visual. Okay, there it is. That's all we need. So let's go outside, save the changes, and then select the bread scriptable object, drag the prefab reference. Okay, for the sprite, this is the bread, and finally just call it bread. Okay, let's do the same thing for the other one. So next up for the cabbage, let's do the cabbage, drag the cabbage scriptable object. Let's go inside and modify the visual. So the cabbage visual. Okay, that's it. Then on the cabbage scriptable object, drag the reference for the prefab. Let's assign the sprite and finally give it a name, cabbage. And finally the meat patty uncooked. So let's do that one. So let's duplicate it, name it meat patty uncooked. Let's go inside, modify the kitchen object SO for this one. And for the visual, let's select, here it is, the meat patty uncooked. Okay, let's go back outside. And on the scriptable object, let's just drag the prefab, assign the sprite. So this one is the uncooked, so it's this one. And finally, meat patty uncooked. Okay, great. So we added all of these scriptable objects. We also have the prefabs with the visuals and the logic script. Now let's just make the container counter. So once again, let's create another variant. So prefab variant, this one is for, let's say for the bread. Then let's make all the other ones already. So let's go make another prefab variant. This one is going to be for the meat patty uncooked. And finally, another variant. Also here, make sure you're creating a variant of the container counter. Don't make an accident of creating a variant of something else. So let's make another variant, one final one. And this one is going to be for the cabbage. Okay, we have all the variants. Now let's just assign them. So let's go inside the bread. And over there, modify the scriptable object for the bread. And for the icon, modify for the bread icon. Okay, let's go to the cabbage, save the changes, modify that one for the cabbage. Go into the icon and modify the icon. And finally, the meat patty uncooked. Let's go ahead, modify this one for that one. And the icon, put it on that one. All right, everything is working. Now let's just place them over here in our scene. So let's get rid of the ones that we made some overrides. So let's get rid of that container counter. Instead, for that one, let's drag the cheese block, put it right in there. Let's put it on X of 1.5, Y of 0, Z of 3.5, okay. Then down here for this one, let's put the cabbage next to it. Let's rotate it to face upwards. So like that. Let's put it on X of minus 1.5, Y of 0, and minus 5 on the Z. Then for tomato, let's get rid of this one and use the proper tomato one. So let's rotate it, put it on X of 0, Y 0, and minus 5. Okay, next we want some bread. So let's put the bread up here on the left side. Let's put it on X of minus 3, 0 on the Y, and 3.5 on the Z. And finally, the meat patty uncooked. Let's put it over here a bit more on the side. Let's put it over here on X of 7.5, 0, and 3.5. Alright, so we have positioned all of them. Let's just make some more clear counters so we can actually place the objects. So let's put this one over here on minus 4.5, this one over there. Let's also put some counters, let's say one on the right side, and a bunch more down here. Let's rotate them upwards. Let's put this one on 1.5, minus 5, and one more over here on the side. Okay, great. So we have all of our container counters as well as a bunch of clear counters. So let's test and make sure that everything works. Okay, so here we are. Let's go down, pick up a tomato. Yep, there's a tomato. Now a cabbage. Yep, there's a cabbage. Now some bread. There's some bread. And some cheese. There's some cheese. And some meat. And yep, there's some meat. All right, awesome. Everything works. So with this over here, we added the ability to pick up and drop objects on an empty container and spawn them from all kinds of container counters. Now in the next lecture, let's build a counter we can interact with in a very interesting way. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to create a cutting counter. So this is going to be a counter where we can place an object, like for example a tomato, and after doing a secondary interaction, we can slice it. However, before we do that, let's just fix one slightly annoying issue. So right now the player is walking around, okay, that's great, I can approach a counter and interact with it, that's great. However, if I approach a counter from the side, look how the player is pointing towards the right. And if I press the double key, I can indeed select it, but the player does not rotate to face the counter. So that's just a minor visual issue, but still I'd like to fix it, so let's do that very quickly. Basically, the issue is over here on our player script, so we scroll down and find our handle movement function, okay. So here we were doing a bunch of capsule casts in order to fix the problem with the diagonal movement. So you try to move in one direction, if not, try to move in just one of those. And if we can move, then we assign the move direction and then move it. Basically, the problem that we have here is that if I press W to face towards the counter, then over here when we do this logic, so it's going to first attempt the X movement only, and the X is going to be 0, so the move there X is going to be 0, 0, 0, so it won't actually move anywhere, which means it won't be able to move. So this one becomes true, which then sets the move direction to 0, 0, 0, which then down here when we have our rotation, it's not actually going to rotate to anything. So we want the player to still not go through any objects, but we only want to modify the move there over here if we actually move in any of these directions. So the solution is actually super simple. So over here for the can move, we can move if there's nothing on there, and if the move direction.x is not 0. So that's really it. If we are attempting to move in the X at all, and if there's nothing on there, then we can move, which means we then assign the move direction. If not, then we don't touch this. And same thing down here. So we can move if there's nothing on it, and if the move there.z is not 0. So that's it, just this one simple change, and now the player should be able to rotate. So here we are, and if I look over there, and the player is currently looking to the left, and if I press W to point towards the container counter, and if there you go, the player does rotate a little bit. So that feels a bit more natural. Alright, so that's just a tiny visual thing that I wanted to fix, okay, so let's keep going. Now let's handle the actual cutting counter. So first of all, as usual, let's make a counter variant. So let's right click on the base counter, create a new prefab variant, call it the cutting counter. Let's go inside of it. And over here, first thing we need is the visual. So let's pick up from the assets the cutting counter visual. So here it is. Then we need the selected. So let's duplicate this one. Let's rename this one to selected. And on the animator, let's get rid of it. And instead add the component, the selected counter visual. Okay, great. Now let's drag the visuals for the visual game object array. And by the way, here's a quick tip. On the right side on the inspector, you can see this nice little lock icon. So if you click on it, then that means this inspector will not change as you select other objects. So I can click on and select something different, and this one does not change. It is still showing the selected object. Now this is useful when you want, for example, to drag multiple things. So you can lock the inspector, then the hierarchy, you can use shift click to select multiple objects, and then just drag them all directly inside the array. That's it, just a nice quick tip. So everything is done, let's unlock it, there it is. Okay, so that's it, let's just assign the selected material. So the counter selected material, let's make it just 1% bigger. So let's select them all, 1.01, okay. And let's start with all of them disabled. Okay, so the basic setup is done. Now let's make our script to run this. So let's go down, let's create a brand new C# script for the cutting counter. Let's select the parent game object and attach the cutting counter, and let's open. Now here, as usual, instead of all this, let's start off by extending the base counter, okay? Once again, thanks to how we set things up using such clean code, this is pretty much all we need to make a counter. With this, the counter already works as a counter. Then next thing we need is to customize any logic specific to this counter by just overriding the interact function. So that's it. Now over here, we can put whatever logic we want just for the cutting counter. And for this one, for stars, it's actually going to be just like the empty counter, meaning we're going to be able to drop objects on this. So let's just go directly into the clear counter. So here it is. And let's just copy all of this code, go into the cutting counter and paste it. Okay, so the exact same logic. So checks if there is a kitchen object or not, checks if the player is carrying something or not, and picks up or drops it. With this, let's do a quick test just to make sure this one is working exactly like the clear counter. So over here, let's just make sure to drag the last references. So on the cutting counter, let's make sure to drag the countertop point. So drag that reference. And then on the selected, drag the cutting counter reference. Okay, everything is good. Let's exit this prefab, make sure to save all the changes. And over here in the scene view, let's place one of our cutting counters. So let's place them right in there. Let's put it on X of 4.5, 0, and 3.5. Okay, so let's test. All right, so here we are. Now if I approach and I interact, nope, nothing happens. Okay, great. Pick up some cheese and drop it on there. And yep, there it is. I can pick it up. I can pick up some bread, drop it, and yep, everything works. Okay, so far so good. Now the next goal is to use the knife and actually slice the object that is on there. And for that, the first thing that we need is we're going to need a different input. Right now, we only have the movement and the interaction, so let's add another alt interaction. For that, let's go into our input action, so let's open it up. And over here, let's make another action. So create a new action, call it interact alternate. And for the binding, let's put it on another key, so let's listen, and I think on F makes sense. So let's go ahead, select this one. Then, as usual, let's make sure to save the asset, which in turn is going to generate the C# class and compile the code. Okay, great. Now we can go here into our game input class, and let's do the exact same thing we did for the interact action. So first of all, let's listen to it. So let's go inside the player input actions, inside the player action map. So this one is the interact alternate, and let's listen to the performed event. Okay, and when we have that, let's fire off an event, pretty much the same thing. So interact alternate action. And down here, let's just fire off this event. So let's invoke using this and event args.empty. Okay, so we have the input for the interact alternate. Now let's go on the player to listen the same way we were listening to the regular interact action. So over here on the player script, let's see how we're doing things. So we go into game input and listen to that. So let's do the same thing, game input and on interact alternate action. Let's listen to this one. And when this one happens, let's do pretty much exactly the same thing, except we're just going to call a different function. So instead of interact, let's call interact alternate, which in turn obviously means we need to define this function. So let's go into our base counter. So here we are on the base counter, we've got the interact, and let's make another one exactly the same, just a different name, interact alternate. Okay, that's it. And now we are only going to implement this in the ones that need implementation. So for example, on the cutting counter, over here, let's override that one. So public override, and let's override the interact alternate. And now here, let's check if there's something placed on here. So if there's a kitchen object placed on this counter, if so, then let's basically cut it. And for cutting it, the simplest way is really to destroy whatever object is on there and just spawn the slice object. So let's handle destroying a kitchen object. For handling that, let's go over here on the kitchen object script. And let's make a simple function for this object to destroy itself. So let's go up here, make it public, return void. And for the name, I like to use the name destroy self to make it destroy this object. And really all we need to do is just destroy and call destroy on this game object. However, before we do, let's make sure to clear the parent. So let's go into the kitchen object parent, clear it, and then destroy the game object. Okay, that's great. It's really this simple. And then on the cutting counter, let's get the kitchen object that is on here and tell it to destroy itself. Okay, so that destroys the object. And after we do, let's just spawn the slices object. So for now, just keep things simple. Let's make a direct reference up here. So let's make a serialized field. Let's make it of type kitchen object SO, and for the cut kitchen object SO. Okay, so we have this. Then here in the editor, let's make sure to drag the reference. So let's go inside the cutting counter. Let's open up the prefab, and inside, let's assign this one. That means we need to create the object. So let's actually do that first. So let's create a brand new kitchen object SO. Let's call it for the tomato slices. Then if we do this, we need to create the prefab. So let's once again do the same thing. Tomato slices, make the prefab. Let's go inside this prefab. Let's modify the visual. So use the tomato slices visual. Okay, and drag the reference for the other kitchen object for the tomato slices. Okay, so the visual prefab is good. And let's just go into the kitchen object. Let's just make sure to drag the prefab reference. Then let's assign the tomato slices icon and just call it tomato slices. Okay, so we have the kitchen object SO. Now we can go into the kitchen cutting counter. And over here, let's open up and set this one to the tomato slices. Okay, so we have all the references. Let's go back outside, save it. And back over here in our code. So we have this. Now we just need to spawn this object. So we're really just going to spawn it pretty much exactly like we did over here on the container. So we just go into the scriptable object, spawn the prefab, and set the parent. So let's do exactly that. Over here, we destroy the object. Then we instantiate the cut kitchen object. And instead of getting into the player, let's put it on this. Okay, so that's it. We should be able to place a tomato directly on top of the cutting counter, and it should be able to transform from a tomato into a tomato slices. Okay, so here we are. Let me pick up a tomato, go up there, drop it, and okay, that works. Now if I press the Alt Interact key, press it, and yep, there you go, it did work. The tomato was destroyed, and the tomato slices were spawned, and I can pick them up, place them anywhere, and yep, everything works. Alright, awesome! So with this, the basics are fully working. Let's just briefly clean up this code. We already saw a little bit of code duplication. So the cutting counter is going to spawn an object, and the container counter is also spawning an object. So we're copy-pasting these two lines of code in multiple places. So instead of doing that, let's put it in just one place. And actually a good place to put this is on the kitchen object class itself. So it makes sense that this one is responsible for spawning more objects. So let's put it over here. However, let us not make it a regular function. Instead, let us make it a static function. Again, just like we saw for the singletons, by making it static, it means that the function is going to belong to the class itself as opposed to any instance. So let's go all the way down to the bottom of the file. Personally, I like to put statics at the end. And over here, let's make public, make it static. We're going to return a kitchen object. And let's call it just spawn kitchen object. And for our parameters, let's receive the kitchen object SO. And let's also receive the kitchen object parent. Okay, so that's it. And we're going to do the exact same thing. So let's go into the cutting counter and copy the code that we were using. And over here, just paste it in there. So we go inside here, spawn the prefab, and set it on this parent. And finally, let's return it. So let's return the kitchen object. Over here, let's pick it up. So the kitchen object, we get it. And then we do kitchen object, set the parent. And finally, we return the kitchen object. Alright, so that's it. Here we have a super simple function that we can call very easily. It will automatically spawn an object and set the parent. So now let's just call this from somewhere. So over here on the cutting counter, instead of doing all this, let's just go into the kitchen object. Again, remember, let's go through the class name itself and not any instance. And over here, let's call the function, pass in the cut kitchen object SO, and for the parent, it's going to be this. Alright, so that is now much simpler. And let's do the same thing over here on the container counter. So if the player is not carrying anything, let's give the player this object and give it to the player, just like this. As usual, when we do some kind of refactoring, let's do a quick test to make sure everything still works exactly the same. Okay, so here we are, and if I go to the counter and pick it up, yep, it does work, does spawn the object. Now I can drop it in there, I can cut it, and yep, there you go, everything does work. Alright, so far so good. So with all of this, basically we have created a brand new counter where we can cut objects. However, right now there's obviously one huge glaring flaw. If I now pick up a cabbage and I drop it on the cutting counter and I interact with it, that cabbage has suddenly magically turned into tomato slices. Now that is obviously not intended, so for that, let's define a proper cutting recipe, and let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to create another scriptable object type. This one is going to be for handling our cutting recipes. So here's our game. I can pick up a tomato, drop it on the cutting counter, cut it, and there you go, slice tomatoes. However, if I could pick up a cabbage, go there, cut it, and there you go, cabbage turns into tomatoes. So we have an obvious issue. The cutting object is currently hard-coded instead of being based on the object we put on top of it. So to solve that, let's make another scriptable object type. Like I mentioned, scriptable objects are excellent for storing and organizing data, so it's perfect for this use case. Basically, we want a scriptable object to hold a reference to the regular object and the cut object, so we can then identify the input in order to spawn the output. Okay, so let's build that. Let's create a brand new C# script, call it the cutting recipe SO, and let's open it. Okay, so now here let's do exactly that, so something extremely simple. So instead of mono behavior, this one is a scriptable object. Let's add the create asset menu. And finally, for the fields, let's do just an input and output. So we've got of type kitchen object SO. Let's go for the input and another one for the output. Okay, so that's really it. Super simple. Now here in the editor, before we create it, let's keep things organized. So let's make another folder. Let's make it for the cutting recipe SO. And inside, let's right click, create a new cutting recipe. Let's call it tomato to tomato slices. And over here, let's select the reference. So the input is going to be our tomato and the output, the tomato slices. Okay, so this is how we're going to handle things. So let's go ahead and make actually the final kitchen object SOs. So let's make yet another one, a kitchen object SO. Let's make it for the cabbage slices. And then let's have another one for the cheese slices. Okay, so now let's make these. So as usual, let's duplicate tomato, make the cheese slices, and another one for the cabbage slices. Let's go inside of it, and first of all, drag the kitchen object SO. So this one is the cabbage slices. And let's go modify the visual. So instead of this one, the cabbage slices. Okay. So we have this. Let's save the prefab, go outside. Then the other one we made, the cheese slices. So let's swap this out. Let's find the cheese slices and modify the kitchen object SO. Okay. So finally, just assign the references. So on the cheese slices, drag the cheese slices prefab. Let's assign the icon and call it cheese slices. Okay, so finally on the cabbage slices, so these are the cabbage slices. Let's pick up the icon and let's drag the prefab reference. Okay, so far so good. We have created our new icons. And over here, let's just make all of the other cutting recipes. So we've got two more. So one is going to be the cheese block onto cheese slices. And the other one is going to be cabbage onto cabbage slices. So all we need is just to drag drop the scriptable objects. So for this one, cabbage, let's drop the cabbage on the input, cabbage slices on the output. For the cheese block, that's the cheese block on the input and the cheese slices on the output. Okay, great. All of our data is now stored in some really nice scriptable objects. So now let's go here into our cutting counter. Instead of having a hard-coded kitchen object, let's receive a field of type cutting recipe SO, except we're going to have multiple, so let's actually make an array of this. Call it the cutting recipe SO array. Now for the interaction, this is picking up and dropping things, so let's leave that the same for now. And over here on the alternate, basically we need to find out which recipe we should apply to this. So how I identify that is pretty simple. So we've got the kitchen object that is placed on this object, and we've got a list of cutting recipes, which in turn has the input. So we just need to cycle through all the recipes in order to find the one where the input matches. Okay, so let's go down here, make a function to do just that. Let's make it private. We're going to return a kitchen object SO. Let's call it get output for input. So we give it a certain input and returns the one that matches that one. So it takes a kitchen object SO for the input kitchen object SO. And now here, let's cycle. So do a for each cutting recipe SO in the cutting recipe SO array. So let's cycle through all of these and just check if the cutting recipe SO, if this one dot input matches the input that we received. If so, then this is the one we want. So let's return the cutting recipe SO dot output. And to make sure that the function works, down here, let's return null. Okay, so that's it. We give it an input and we get back the output. So now up here, we just need to make sure to do it before we destroy the current kitchen object. So let's store a kitchen object SO for the output kitchen object SO. And we just get the output from the input. And for the input, pass in the get kitchen object. So that's the one inside of this cutting counter. And let's get the kitchen object SO. So that gives us the output. And then we just spawn that output. Okay, so that's it. Let's test. Finally, back in the scene, let's just go inside the prefab. And over here on cutting counter, we need to make sure to add all of the recipes. So let's add, so the cabbage, then a second one for the cheese block, and finally for the tomato. Okay, so there are all of our recipes. Let's go outside, save the changes, and let's test. Okay, so over here, let's pick up a tomato, go up there, slice it. There you go, got some tomato slices. Now pick up some cheese, go here, slice it, and there you go, got some cheese slices. And finally the cabbage, go up there, slice it, and there you go, some cabbage slices. All right, awesome. So everything is working perfectly. However, now let's say that I want to pick up some bread, and bread should not really be able to be cut. So if I go ahead and I cut it, and there you go, there's our error. We have no recipe that takes bread as an input, so that obviously leads to a null reference exception. Now here we have two options for solving this problem. One option is simply over here when we do the interact alternate. We get the output for the input, and if this one returns null, then we just don't cut it. So we don't destroy it and we don't spawn it. Or alternatively, we can actually add some validation over here when dropping objects. So we can make sure that we only drop valid cuttable objects. Now both approaches are valid, and actually we do need to implement both of them. We'll see why in a bit. So let's do both, starting off with the validating the drop. So first we check if there's no kitchen object on this cutting counter, then we check if the player is carrying something, and then we drop it from the player on this. So over here, let's just check if there's any recipe that has whatever the player has as an input. So let's go down here, make a function to do that, private, let's return a bool, and call it has recipe with input. And we're going to receive a kitchen object SO for the input kitchen object SO. And over here, let's do pretty much literally the same logic. So we have this, and if we find a match, then let's return true. So there's a recipe with that input. If not, return false. So now up here, when the player is carrying something, let's check if has recipe with input and give it the player, get the kitchen object the player is holding, and get the kitchen object SO. So if there's any recipe that takes whatever the player is carrying as an input, if so, then we drop it. Okay, so like this, let's test and see if we can drop the bread. Okay, so let's pick up some bread, go ahead, drop it, and nope, does not work. Pick up some cheese, and yep, that one does work. However, now we actually also need the other validation that I mentioned. The reason is because if we place a valid object, like for example the cheese there, so that works, and I can cut it, and yep, that does work. However, now the recipe, the cheese block, became cheese slices, and now cheese slice is no longer an input to any cutting recipe. So now if I try cutting again, yep, there you go, I've got another null reference exception. So we need to validate putting objects on top of it and also actually cutting them. That logic is also pretty simple, so let's go down to the interact alternate. So we just check if there's a kitchen object on the cutting counter and has recipe input. And let's get this kitchen object, get kitchen object SO, just like this. So we're only going to cut if there is a kitchen object here and it can be cut. Okay, so let's test. So first of all, the other one, let's pick up bread and nope, cannot drop. Okay, great. Now pick up some cheese and I can drop. Now interact, cut, now cut again. And yep, there you go, no more errors. All right, awesome. Okay, so here we have everything working perfectly. I can pick up a cabbage, go up there, cut it into slices. I can slice some cheese and I can even slice some tomatoes. Everything works perfectly. Now, the one thing missing from our design is we don't actually want this action to be instant. We don't want to just press a button, everything slices instantly. Instead, we want to have the player press the button a few times in order to actually cut. So let's do all that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to add the mechanic for the player to be able to cut multiple times in order to actually cut an object. Okay, so we have our cutting counter. I can drop a tomato and press a button. There you go, it cuts it straight away. Now we want the exact same logic, but we want it to take a few cuts before the cut object is spawned. So let's start off by going here onto the cutting counter, and basically let's keep track of some kind of progress. Basically the way we do that is pretty arbitrary, it's up to you to decide. For example, you could use a normalized float. However, for cutting, since this is going to be a discrete action, let's actually count the numbers with an int. So let's store a private int, just call it cutting progress. Okay, so now let's begin by actually initializing this progress. So when the player drops something on there, let's set this one to 0. And then down here, when we have the interact alternate, we do our logic, and when we do, let's just increase this by 1. And now we need to know if the object has been cut, so we need somewhere to define some kind of maximum. And for that, we can actually do it directly on the recipe SO. So inside the cutting recipe SO, over here we've got the input, we've got the output, and let's also define an int for the cutting progress max. Okay, that's it. And back here in the editor, let's go into the tomato to tomato slices. Let's say this one takes just 3 cuts. Then for the cheese, let's also take 3 cuts. And for the cabbage, let's say it's a bit thicker, so let's say it takes 5 cuts. Okay, so back in the cutting counter here. Down here, we are adding to our cutting progress. So then we just need the recipe SO in order to grab the maximum. So let's actually go down here and actually make a different function. So this one just returns a boolean. This one a kitchen object SO. Let's make another one. This one is going to return a cutting recipe SO. So get the cutting recipe SO with input. And we're going to receive, as usual, the kitchen object SO for the input. And really going to do the exact same thing that we did up here, except instead of returning the output, let's return the recipe itself. Okay, so now that we have this more logical one, we can actually get rid of all of this copy-pasted code. So over here, we just get the cutting recipe SO, and we just get it and pass in the input. So we have this one over here. If this one is not null, then we're going to return this one .output. And if not, we're just going to return null. Okay, so we're doing the exact same logic, just a bit simpler, okay? And up here, pretty much the same thing. So has recipe with input. Let's get the cutting recipe SO. And basically just return if this one is not null. Okay, so we have our 3 nice helper functions. So let's just use this one to get the cutting recipe SO. So let's actually copy this and go up here. So we do the cutting progress. Then let's pick it up, the one for this input. So the input is going to be this one, the object currently on the cutting counter. And over here, we already know that there's going to be a recipe with this input since we've gone through this if. So then we can just check if the cutting progress is bigger or equal to the cutting recipe SO, and let's grab the maximum. If so, then yep, we do spawn it. Okay, so that's it, some very simple logic. Let's test. So here we are, let's pick up a tomato, go up there, and okay, now I'm going to press the alt to interact. Okay, press once, and yep, okay, so far so good, nothing. Now 2 times, and now if I press a 3rd time, boom, and yep, there you go, got the nice slices. Now for cheese, same thing, 1, 2, 3, yep, it works. And finally for the cabbage, this one should be 5. So 1, 2, 3, 4, and 5. And yep, there you go, everything does work perfectly. All right, awesome. So with this, we now have progress in our cutting logic. Although, of course, just like this, it's not very good for the player. The player has no way of knowing what exactly is going on, so we need some kind of visual feedback. So for that, let's add a really nice visual progress bar. And for doing this, we're also going to learn about a really awesome Unity feature. These are world canvases. So before we make the world canvas on the cutting counter, let's actually set something up over here on the scene itself. Let's first create a regular canvas. We're only going to use this in a couple of lectures, but let's first do that one just for now. So let's go on the plus button, go into UI, and let's create a brand new canvas. Okay, so there you go. That creates a canvas and an event system. Now, like I said, we're only going to worry about this in a little bit, but for now, let's just leave those as is. And also, since we're here creating some objects, let's also take some time to organize our hierarchy. Unity sadly doesn't really have any folder objects, so you can't organize the hierarchy in any folders. However, you can use empty game objects essentially as folders. So let's make a brand new empty game object. Let's call it counters. And now, very importantly, for empty folder objects, make sure you put them on 000 so nothing breaks. So make sure you put it on there before you drag the counters. And now let's just drag all the counters inside. So all the clear counters, put them all inside. This one, also drag it inside. And all of these counters, put them all inside. So there you go, and our hierarchy is quite a bit more clean. Okay, so now let's make the cutting progress. So let's click on the cutting counter. And let's go inside our prefab. So let's go inside of it. Now over here, let's right click on the hierarchy and we're going to create a UI. Let's create another canvas. Now for this one, let's give it a name. Let's name it the progress bar UI. And for this one over here on the inspector for the settings, instead of being screen space overlay, let's make this one a world space canvas. Basically, screen space means that it would occupy the entire screen, whereas world space means that this exists in the world in whatever position it is. So let's make it world space, and over here the fields actually unlock. So let's put the positions all on 0, and for the width and height, let's also put it on 0. So basically the canvas is going to be exactly over here. By the way, the shortcut that I just used was the F in order to focus on the object. So this is useful if you're zoomed out or zoomed in way too much, okay? So we have this and we want the bar to be a little bit above, so let's actually lift it up on the Y by a little bit. So over here, let's put it on a Y of 2.5, okay. Now, like I said, the goal with this is to make a progress bar. So inside the progress bar UI, let's create a new UI image. Let's name this one our bar. Let's put it with a width of 1 and a height maybe of 0.2. So there you go, just a really thin bar. And for the color, you can play around, tint it with any color you want. Now for progress, I think maybe a blue or a yellow, something like that makes sense. So let's go with the yellow, kind of like this. Okay, so there's our really nice progress bar. And for this, let's actually use one really nice trick for making a super easy progress bar. The image component has a really easy way of making a slider image. However, it only actually works if you assign an image over here. So let's assign one in order to be able to see those options. And for that, in the included project files, there's a texture white 1x1. This is literally just a 1x1 white pixel. So here it is, just a 1x1 image, fully white. And as soon as we assign it, we do see over here the image type. So we see a bunch more options. And the one that we want is to set the sprite as filled. This one lets you do some really cool, really easy effects. For example, you can make it radial, and look at what happens in there as I modify over here on the fill amount. So as I go down, look at that, it's radially filling. So for some kind of circular progress bar, this would be excellent. But in our case, what we really want is just a horizontal bar. So over here for the fill method, instead of radial, let's go with horizontal. And yep, there you go. Now by playing around this, we have a really nice progress bar. Then if you want, you can modify left to right, right to left, but yep, like this, it looks great. Now in order to modify this visual, really all we're going to need is modify over here the fill amount. This one is a normalized value, so between 0 and 1. So 0 is completely empty, 1 is completely full. However, one issue with this is when the bar is empty, then we can pretty much not see, so we can't see the actual size of the bar. We can't see what size it should be. So with this, it's pretty difficult to see how far along we are. But solving that is pretty simple. We can really just add some kind of background. So let's duplicate the bar. Let's name this one the background. For this one, for the image type, we don't want anything, so let's leave it on simple. And for the color, let's put it on kind of a dark gray. Okay, great. And now here's one very, very important thing, is over here on the hierarchy, let's click and drag and place it above the bar. The reason why that is super important is because the sorting order and how it works in Unity. Basically, when it comes to UI elements inside a canvas, the sorting order is based on the order in the hierarchy. Basically, it renders from top to bottom. So the bar on top, the background, this is going to render first, and then the one below it, the bar, is going to render afterwards, which means it's going to render on top. So for the background, we want it to be behind, so place it above on the hierarchy, and that way it renders the background and then renders the bar. Also, by the way, for 2D sprites, Unity has another different sorting method. It's all based on sorting layers and sorting orders. I have a video on that topic if you're interested in 2D games. Okay, so with this we have the background and then we have our film bar. This way we can see if the progress is being filmed or not. Also, one more tiny thing that I like to add is Unity has some really nice, really easy to add effects. So you can go into Add Component and let's search for a shadow. This one does exactly what you expect. It adds a nice drop shadow. Over here on the effect distance, let's put it on 0.1, 0.1 in order to see. And actually, let's not do it on this one, but do it on the background. So let's get rid of this. Instead, going to the background over here, let's add the same shadow. So if you put it on 0.1 and minus 0.1, yep, there you go, a nice simple drop shadow. Or the other one that I prefer, so instead of the shadow, let's add a really nice outline. Once again, for the effect distance, 0.1, 0.1, or maybe actually 0.05, just to be just a tiny bit. And let's raise it on the alpha, so there you go, nice little outline to our bar. This is just a visual thing, so you don't have to add this, but personally I find that it looks pretty good. So with all of this, we have our visual perfectly set up. We've got our nice bar. All we need to do is play around the fill amount in order to fill it. So now all we need to do is to connect this to the logic. But as usual, let's make sure to write some good clean code. So we do not want the cutting counter to directly touch on this image. Instead, let's make a script to handle that. So let's right click, create a new C# script, call it the progress bar UI. And just personally as a rule, I like to append the UI to any UI script. You don't have to do that. It's just a rule that I personally find helpful to follow. That way, just by looking at the scripts, I can immediately see this one is a UI, this one is script and logic, and so on. So on the progress bar UI, on the main game object, let's attach the script and let's open it. Okay, so now here we're going to need a reference to our image. So let's add a serialized field, private, and we're going to need the image type. And importantly, this is inside using Unity Engine.ui. So let's go up here using Unity Engine.ui. So we have our image component. Okay, great. Let's call it the bar image. So we have our reference. And now with this, obviously, we need to have some kind of reference to the counter so we know when the progress changes. So it's really the same thing that we've already done so many times throughout this course. So let's add a field up here, serialized field, private, cutting counter for our cutting counter. Then over here in the editor, let's drag the references. So drag the reference to the cutting counter and another one to the bar image. Okay, great. Now we just need some kind of event to update the bar image. So let's go over here into our cutting counter script. Let's make an event to spawn that. So public event, let's use the event handler, the default standard. Let's call it on progress changed. And let's also make a nice event args to be able to send the current progress amount. So let's make a public class on progress changed event args, and let's extend event args. And then inside it, let's put the current progress. However, let's also pass in the progress as normalized, since that's what the bar will use. So public float, progress normalized, and we're going to make this event of this type. Okay, great, so we have our event. Now whenever we modify the progress, we just need to fire this event. So over here, when resetting the progress, let's fire it. So let's invoke, pass in this, instantiate our event args, and pass in the progress normalized. And to get the normalized progress, it's actually very simple. Basically, we just need to divide the current progress by the maximum. So cutting progress divided by cutting progress max, which is actually inside the recipe SO, so we need to pick that one up. So let's go down there to pick up the cutting progress recipe. So we pick this one up and we go in there and get the maximum. However, over here we also need to be very careful because there's one sneaky issue here. This has to do with how C# works and how ints are divided with other ints. For example, if we had a cutting progress of 1 and cutting progress max of 5, you would think 1 divided by 5 would equal 0.2. However, if we actually did that, over here we would actually get a 0. And the reason for that is because we are dividing two ints. Cutting progress is an int, cutting progress max is also an int. And if you divide an int by an int, then the end result will also be an int. Since you cannot define 0.2 in an int, the decimal gets cut down and you end up with just 0. So that would not be correct. In order to get the right value from this calculation, we need to make sure to convert one of these values onto a float. So that's really simple, we just cast one of them, so just cast this one to the float, just like that. Basically now this one will first be cast to a float, and then we're going to have a float divided by an int, and the end result will be a float. So if you ever do some math and you get some weird results, always make sure to check the type of your numbers. Okay, so here we are correctly firing the event, and then down here when adding our progress, let's do the same thing. Let's also fire on the event. So now we can go back into our progress bar UI, and over here let's listen to the event. And again, remember that if we're accessing an external reference, let's do that on start and not on awake. So cutting counter, listen to the on progress changed event. When that happens, let's just go bar image and set the fill amount to what we receive from the event, so the progress normalized. Okay, so that's really it. And also up here on start, let's initialize it as 0f, so the bar is nice and empty. Okay, so let's test. Back in the editor, let's just go back into the scenes, make sure the prefab has been saved, and let's hit on play. And right away, yep, we do see the bar. Yep, it is empty. Now pick up some cheese, drop it, and if I cut, and yep, there you go, added a little bit of progress, now a bit more. And there you go, there's our cheese. Okay, great, everything does work. Now let's add just one more tiny bonus thing. We can add some extra logic in order to hide this visual if the bar is either completely empty or completely full. That is actually pretty simple. Over here on the progress bar UI script, let's just make some basic show and hide functions. So private void show, and then we're going to have a private void hide. On these ones, just game object set active, this one set it to true, and this one set it to false. Now on start, we subscribe to the event, and then let's hide it, okay? Also here, it's very important, make sure you hide it after you listen to the event. If, for example, you called hide on awake, that would disable the game object, and the start would never run, so it would never listen to the event. So if you ever set the game object as inactive, make sure you do it only after you're listening to whatever events you want. So we have this, that's great, and then when the progress changes, let's just do a basic test. So if e.progressNormalized equals 0f, or if the progress normalized equals 1f, so if the bar is completely empty or completely full. If so, then let's hide it, and if not, then let's show it. Okay, that's it, let's test. Okay, and yep, by default starts off hidden. Let's pick up a tomato, go up there, and yep, still hidden. Now I cut, and there you go, there it is, cut again, and yep, there you go, it hides itself. Okay, great, so we've got a nice little visual. Let's do just one more final thing. Let's add a really nice animation. If we go inside the cutting counter, and we look at the cutting counter visual, over here, note how it already has an animator. Just like we did for the container counter, it's all very simple. So basically just has a cut parameter. When that happens, it just cuts the counter. So it just plays a simple animation. Since it's going to be pretty much exactly like the container counter, let's actually duplicate that script. So let's go down, find that script. So the container counter visual, let's duplicate this. So Control D. Let's rename this to the cutting counter visual. Okay, let's open. And over here, let's rename the script. So the cutting counter visual. Okay, great. Then for the parameter, let's rename this. Instead of open close, it's going to be called cut. And for the string, it's cut. Again, make sure you write it case sensitive. Make sure it's all correct. Then instead of having a container counter, we've got a cutting counter and a cutting counter. And finally, we just need to listen to the correct event. So technically, we could listen to the on progress changed. However, that one also gets fired over here when the cutting progress is 0. We don't want the cut animation to play when this happens. So let's just make another simple event. So a public event handler. Let's call this just on cut. Okay, and then down here when we have our cutting progress, so we cut and let's just invoke this event. Okay, that's it, super simple. So now on the cutting counter visual, let's go into the cutting counter and into the on cut event. Let's listen to this. And we're going to set the trigger exactly like this. So get rid of the container counter like this. Okay, there you go, a very simple script. So now here back in the scene view, inside the container counter prefab, let's just go inside the visual. Let's attach the cutting counter visual. Just need to drag the cutting counter reference, and that's it. Let's exit the prefab, save it, and let's play. Okay, so now let's pick up a cabbage, go up there, drop it, and Alt Interact. And if there you go, we've got a nice little animation. All right, awesome. So I can drop things, I can cut them, and everything works perfectly. All right. So here we added a cutting progress to our cutting counter, and we also learned about yet another very useful Unity feature called World Canvases. And at the same time, you might have also noticed that the canvas is looking at the camera in kind of a weird way. basically just pointing straight forward. This can sometimes make it difficult to see, so let's work on that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to build a very simple but very useful script to make an object look straight at the camera with various options. Okay, so we previously made the cutting counter, and when I place something, yep, there's a nice progress bar. So now that this is working, let's do one more thing. Right now, look at how the bar is oriented. It's looking quite a bit slanted. That's because we have a perspective camera and it's looking from top down. Now, this is one of those things that is kind of personal preference, so maybe you don't like it just like this. But a lot of the times you want these World UI elements to face the camera just like a regular UI. One example of this problem is, for example, let me pick up the cutting counter, duplicate it, and let's put one down here. So rotate it upwards. Okay, let's put it on 4.5, 0, and -5. Now if I place something on there and I cut it, yep, look at that, the bar is now inverted. So let's make a simple script to solve this problem. Let's go into our scripts, create a new C# script, call it look at camera. Let's go onto the cutting counter prefab, let's open it up, go inside, on the progress bar, let's attach this script, so the look at camera. Okay, now let's open. So from here, let's use an interesting function. So let's use a private void late update. So not update, we have the late update. So if this is the first time you're hearing about this, like the name implies, this one is going to run after the regular update. So every single update and all the objects is going to run, and then all the late updates. So kind of like you've got awake and start, you have update and late update. Why this is useful specifically for this script is because for this element you really want this to run, the orienting logic, you want that to be done after whatever that object does in the update. In this case this object will never move, so it's not really an issue. But for example, if you had some kind of moving vehicle with a world canvas on top, if you had that, you would want to set the world canvas location to look at the camera after the vehicle had moved. Otherwise the canvas would not look perfect. So anyways, because that here we're doing on late update, and now we can just look straight at the camera. So we can just do transform.lookAt. And for the target, pass in the camera.main.transform. This function makes this transform look at another transform or another point, so this will make it look straight at the camera. Also, by the way, one quick note here. In some older tutorials, you might see people telling you not to use camera.main. The reason for that is because this field did not used to be cached. So every time you use this, it would cycle through every single game object in the scene until it found the main camera, so that was obviously really bad for performance. But nowadays this field is now cached by default on the Unity backend, so you no longer need to cache it yourself. Accessing it directly just like this is now fine. Okay, so with this let's test. Just make sure to save the prefab and let's hit on play. Let's go ahead, pick up a cabbage, put it up there, and if there you go, look at that, how it's looking straight at the camera. And for this one down here, same thing, cut it, and yep, there you go, both of them are looking straight at the camera. Okay, so that's great. You can also see exactly what it's doing if we try to move the camera. Again, we're using Cinemachine, so let's move the virtual camera. So over here, if I just play around with the position.x, look at that, look how as I move the camera, yep, the objects are perfectly looking straight at the camera. So that's great, that's what we want. But also you might notice one thing, notice how the bars are actually inverted. Instead of going left to right, they're actually going right to left. Basically, this has to do with how the canvas by default assumes you are essentially going to look at it from behind instead of looking forward. So that is why when this game object is pointing straight at the camera, it's essentially inverted. So to solve this, it's actually quite simple. We basically just need to look in the exact opposite direction. But at the same time, sometimes we might want this exact behavior, having something look straight at the camera. Maybe we do want it to be inverted sometimes. So for that, let's make a nice complete script with all of our possible options. And for defining options, this is also an excellent way to learn about one more thing, which are C# enums. Enums are an enumeration, meaning a fixed set of options that you can have of something. So these are really useful when you have a fixed set of something, like for example, maybe a fixed number of options. So for example, up here, let's make it private, make it an enum, and let's call it mode. And then inside we can define all of our options. So let's say we have the regular look at and then look at inverted. Okay, so we have these two options in our enum. Now let's do a field of this type and expose it in the editor. So let's make a serialized field, private of type mode, and call it mode. Okay, let's save this and look what this looks like in the editor. And if we go inside the cutting counter and we look at the progress bar, you will look at that, the mode shows up and it shows up as a really nice drop-down menu. So since we have a limited number of options, we've got a really nice menu where we can choose each one you want. So that's really awesome. That's one of the benefits of enums. They are really easy to use over here in the editor. Now back in the code here, let's decide which one to use. So on the late update, let's just do a switch on our mode. In case we are on the regular look at mode, then let's do exactly this. Let's simply look at it. In case we are on the look at inverted, for this we just want to look at the inverse position. So that's actually pretty easy. We just calculate the direction vector from the camera to this object. So a vector 3, call it dir from camera. And to get direction from the camera, we start from this object, so this transform.position, subtract the camera.main transform position. So this gives us the direction pointing from the camera. And then we just do transform.lookat. And instead of looking at the camera, let's look at the opposite position. So let's look at transform.position, so our current position, plus the direction from the camera. So we're going to be looking at the exact opposite point. Okay, so that's it. Let's test. And right now, by default, we have the regular look at. So let's just see it. Let's just place some objects. Okay, so right now it's still inverted. And something really nice is you can play around the enums even as the game is running. So let's go inside the cutting counter on the progress bar UI. For this one, let's swap from look at to look at inverted. And yep, look at that. That one is now looking perfectly. So this one is using look at and this one using look at inverted. Okay, great. It's all working. However, yet another thing that is all about personal preference. Note how the visual has a slight slant. This is due to how the visual is actually looking directly at the center of the camera. So you can really see it if I move the camera left and right, how it slants going left or going right. Again, this is all personal preference, it's just a visual, so maybe you do want this look. But let's see another method. So over here in our modes, let's add two more. Let's add camera forward and camera forward inverted. And then down here on our late update, let's add those. So the camera forward, and then we have the camera forward inverted. So for this one, for the camera forward, super simple. Let's just take this transform, use the forward, which again you can get or you can set it. And let's set it to the exact same one as the camera.main.transform.forward. And for the inverted, exactly the same thing, except instead of forward, we do minus forward. Okay, so let's see what this looks like. Okay, so here's the game with both counters. They're both currently using the look at mode. Now if I put it look at inverted, yep, that one goes left to right. Okay, great. Now if I put camera forward, yep, look at that. Now that one is perfectly straight. So even as I move the virtual camera left and right, look how that one is always perfectly facing the camera as if it was a regular UI element. And for the inverted, does the exact same thing, but inverted, so just like that. So that's it. These are the four modes. Again, these are all just visual elements, so pick whatever you prefer. For me, I'm going to be using this one, the camera.forward, so that everything is perfectly horizontal. So I'm just going to make sure to go inside the prefab, and on the prefab itself, modify it and set it as camera.forward. And now if I add a cheese there, yep, looks great. And if I add a cabbage here, and yep, it also looks great. Alright, so here we created a really nice, useful, generic script to make an object look straight at the camera in various ways. Note how this one has nothing to do with canvas or a progress bar or anything. It's really a generic script to look at the camera, so you can apply this to anything where you want it to look at the camera. Okay, so with that, the cutting counter is fully done. Now let's handle the trash counter in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, let's create the trash counter. This one is actually pretty simple. It's how we're going to drop something and just destroy it. Okay, so making the trash counter is going to be super easy. Once again, going to be another great practical example of the power of writing good clean code and having good organization in your project. So let's do the same thing that we've already done a bunch of times. So first of all, let's make the prefab variant. So let's right click on the base counter and create a brand new prefab variant. Call it the trash counter. Okay, let's go inside. And first of all, let's drag the visual. So find the visual prefab on the trash counter. Okay, then let's duplicate it to make the selected. So let's rename this to selected. Let's add the selected counter visual. Let's add the visual inside of it. And on the visual, let's select the other material. So the counter selected. And finally on the selected, put it 1% bigger, 1.01. And start off with visual disabled. Okay. So that's the basics, just like we've already done so many times. Now let's make the script to run this. So let's right click, create a new C# script, call it the trash counter. And by the way, here we're already starting to have quite a bunch of scripts, so we should probably organize this scripts folder. So let's make a new folder. Let's call it counters. And let's make another one and call it scriptable objects. So on the counters, let's drag the base counter, clear counter, the container visual, the cutting visual. Then down here, the trash counter. Okay, let's drag them all onto the counters folder. And on the scriptable objects, let's put the cutting recipe and the kitchen object SO. Okay, now our folder is a bit more organized. So let's open up the trash counter. And over here, as usual, let's begin by extending the base counter. Okay, great. Then let's implement the regular interaction. So override the interact. And on this one, again, it's going to be super simple. We just check if the player is holding something, and if so, we destroy it. So just check if player.hasKitchen object. So if the player is holding something, go into the player, get the kitchen object the player is holding, and simply call destroy self. And that's it, it's this simple. Back in the editor, let's just attach a script. Let's make sure to drag the countertop point reference, and on the selected, drag the base counter reference. Okay, with this it should be working, so let's exit the scene, let's save the prefab, and let's drag it over here onto our scene. So let's drag the trash counter and put it maybe somewhere over here on the corner. So let's put it here on an x of 7, y 0, and minus 3.5. Then let's also fill up these spots down here. So let's duplicate the clear counter, put one in there, put another one in there. Let's put another one on the side, and for the trash counter, let's align it. So let's put it a bit more to the side, so on 7.5. Okay, great, and let's put it inside the counters, and now we can test. Okay, so let's see if we can interact with it, and yep, as I approach, yep, I do see it highlighted. Okay, great, and if I interact, obviously nothing happens since the player isn't holding anything. Now if I pick something up, let's say a tomato, and I don't want this tomato, so I want to trash it, and yep, there you go, it does get trashed. Alright, awesome, so this is literally it. Like I said, this is once again another excellent example of the power of writing good, clean code. This was super simple to implement because we have a really nice structure for how all of our counters work. Also because our interaction system is very well built. Also because the kitchen object system is very well made. It's because of all of that great, very clean code that we were able to implement a brand new counter in literally about 60 seconds. So once again, I hope that by following this course, you now understand why I'm always talking about the importance of writing good, clean code. It's exactly because of this. If you write your code correctly, it makes developing the game so much easier. At first, it might seem like the quick and dirty approach is faster, and usually in the beginning it is faster, but as soon as you add some complexity, the quick and dirty approach suddenly won't scale, whereas the well-built, clean code approach, this one will continue scaling very well. So here we have a fully functional trash bin so we can dispose of unwanted objects. Next, let's build a much more complex counter. Let's build a stove counter, which also requires building a really nice state machine. So let's do that in the next lecture. Hey again, another quick intermission. You're past the halfway point, so congrats again. By now, I really hope you've already learned a ton from the course. We've already covered lots of topics and built a ton of systems. I hope you've been following the website as you go through the lectures, and I hope reading the frequently asked questions has helped you in some way. Let me know in the comments how you've used the course website. Did you just read the FAQ, or did you also download some project files? Let me know, I'm curious to know. If you enjoy my teaching style, also look at my other courses after finishing this one. Especially the turn-based strategy course, that one is an excellent follow-up for this one. Okay, there's still quite a bit more for us to build and learn, so let's continue in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build the stove counter. So we want to place some uncooked meat, then we wait for a bit for it to be cooked. However, if we wait too much, it's going to get burned. So let's implement that. Alright, so as usual, let's first begin by making our counter. So let's go inside the prefabs, the counters, let's right click on the base counter and create a new prefab variant. Call this the stove counter. And as usual, let's go inside of it. Let's find the visual. So inside the prefab visuals, the counters visuals, here is the stove counter, so let's drag it. Then let's duplicate this, rename this one the selected. Let's set the component, the selected counter visual. Then let's go inside on all of these. And by the way, this visual actually has some nice visuals that we're going to implement in a little bit, but for the selected, we really just want the static objects. So let's pick up all of these and let's select the counter select visual, okay, nice and white. Then let's lock over here the parents so I can select all of these and drag all of them, okay, great, and start off with all of them disabled. Okay, so that's the basic setup as usual. Just for the counterpoint, Since this one has a nice little sub on top, let's lift it up by a little bit. So put it on a Y of 1.456. Okay, that looks pretty good. Just move it a little bit to the center. Okay, great. So now let's make our script. So let's go inside our scripts folder. We've got our counters. So in here, let's create a brand new C# script for the stove counter. Let's wait for it to compile. Let's attach the script and open. Okay, so here as usual, let's extend the base counter. Now, like I said, the goal for this one is to be able to cook our meat, and for that it's going to be based on a timer. And to actually cook the meat, we're going to need to know which one is the uncooked meat type and which one is the cooked meat type. So for that, we really want the exact same logic that we did for the cutting action. We want some kind of place where we can store an input and output as well as a cook timer. So for that, let's actually just duplicate. So let's go inside our scriptable objects for the cutting recipe and let's duplicate this one. So Control D. And let's name this one the frying recipe SO. Okay, let's go inside. And over here, let's rename the object. Then we have an input, we have an output. And then instead of progress, let's have the frying timer max. And since this one is a timer, instead of an int, let's make it a float. Okay, so that's it, pretty simple. Then back here in the editor, let's create our scriptable object. So let's go inside, let's make a nice folder. So a folder for the frying recipe SO. And inside, let's create one. So let's create a brand new frying recipe SO. For this one, let's call it meat patty uncooked into meat patty cooked. Then for the inputs, let's choose the meat patty uncooked. Now we have to make the other one. So let's go ahead and make that one. Let's duplicate this one, rename it to the meat patty cooked. And the object name, meat patty cooked. Let's select the different sprite. So this one is going to be the meat patty cooked, okay? And finally for the prefab, let's also make it. So for the meat patty cooked, let's go inside of it and also make sure to save the changes on our stove counter. So okay, now in here, let's get rid of this visual and use the other visual. So we want the meat patty cooked, and let's make sure to drag the scriptable object. Okay, so it's all good here. Let's go back outside, save it, and finally over here on the meat patty cooked, let's just grab the prefab reference. So there you go, that one. Okay, so this one is working, and since we're here, let's actually make the other one right away. So let's make the meat patty burned. So the prefab, and let's also duplicate this to make the meat patty burned. Then on the text, let's rename this to burned. Let's choose the burned icon. And for the prefab, let's go into our meat patty burned and swap it out for the burned one. So there you go, nice and charred. And over here, swap it for the meat patty burned. Okay, let's save it. And finally down here, just make sure everything is correct. So the meat patty burned, just drag the scriptable object, the transform prefab, just like that. Okay, so all of our burned references, over here all of our cooked, and over here all of our uncooked. And again, when going through this process, always make sure that you match all the references on the scriptable objects and also over here on the kitchen objects. So meat patty burn, yep, meat patty burn for the uncooked, and for the cooked, there it is. Okay, everything is good, great. So now we can go back over here into our frying recipe SO, and for the output, let's output the meat patty cooked. And for the frying timer, let's put it on 3 seconds. Okay, so that's it, great. Now back in the code here on the stove counter, let's add an array of our frying recipes. So a serialized field, private, it's going to be an array of frying recipe SO, so frying recipe SO array, and call it frying recipe SO array. Okay, great. Then back here in the editor, let's go inside the stove counter.